So now we've started the recording and we can start talking about the manual here and how it's structured very quickly. I'm not going to bore you with a lot of stuff, but you can see in the table of contents that, there's certain things like here's the general menus, file menus, and you see how that little icon switches there. So these are hyperlinked. And so it takes you over to here's that file menu under the general menu type. Right here was where this took you. So, you can bounce your way around there from the table of contents. On some things, some of these links appear to have gotten broken. So maybe you ought to recompile the manual at some point. But some of those work, but you can jump your way around there as well. Um, the other part of this is now those of you like Sarah and Scott Steele, that if you from your class last week, the fundamentals class, this is going to look very familiar to you because you've got all of this stuff up front and you come down, it goes through these points, exercises, these surface modeling exercises, concluding with that putting it all together exercise that you see down here at the bottom of the page. Well, and at that point, your manual went straight over to this command reference, or down here at the bottom. But this manual has this additional survey specific content, and that's where we're going to do most of our focus for this class. We'll obviously, be using some of those fundamental skill sets and things that we developed from that. And those of you new, and maybe this is your first exposure to it, if you're really not coming from the, uh, if you haven't had the fundamentals class, um, we're not going to have time to go into that stuff in depth like we do in that class, but we'll do what we need to get through this. So some of that may be stuff you want to, focus on later. So you have all of that information in this book, including the data sets and the exercises that were part of that class as well. So you may have to, do a little self-study after the class to sort of reinforce some of that, but that'll be part of that. So, um, and then and like I said, this big one here, field to finish, is going to be one of the key aspects that we want to learn is to make sure we can do that as part of our workflow, because that's going to be very, very helpful when we're working on some things. And then we'll go through that. At the end of these exercises, it switches to this command reference section. And there's in parentheses here the general menus. That's file, edit, view, draw, inquiry, settings, and points. Those are the seven general menus that are always part of every Carlson module. And then it continues with these survey module specific menus that follow after the points menu. You've got survey COGO, centerline, area layout, annotate, surface, and GIS. There's also, window and help, or the window menu and the help menu. And if you've run in the C&G interface, you'll see that C&G menu. Um, so that's the nature of the book. If we are in this sort of getting started thing, you'll see a couple of little icons like these here on the this lower right. If you see that little icon, that may be a specific thing that's specific to the IntelliCAD version versus the AutoCAD version. I don't know that there's more than one or two of those in the book. I can't remember. It's not anything that makes it functionally different. It's just some slight differences that you might need to be aware of. The um, the remainder that you want to sort of keep a track, an eye open for, are these little icons. If you see a little light bulb, it's one of those good ideas, a little tip or trick, or a notepad saying, hey, take note of this, it's important. So you'll see those. This business down here about what's bold-faced and gray field and all that, that'll become second nature just from looking at it. The context of it, when you see that, will explain itself. This next bit about Carlson, and again, I'm not going to read you this page, but it basically talks about Carlson being the interface between us as a practitioner of whatever we're doing, contracting work, surveyor or an engineer, um, and it's between us and the underlying CAD system in the background, because the CAD system is, deaf, dumb, and blind to what we're doing. It does not know anything inherently about what we do because it doesn't care. We could be drawing maps, we could be drawing circuit boards, we could be drawing dress patterns. It doesn't know or care what we're doing, molecular uh, modeling, um, or something from astrophysics. It has no idea. So this is the system. The Carlson system is what sits between us and it, and we don't have to know that esoteric system as deeply as we would otherwise have to. And it gives us a lot of computational power to, we offload what we know can be done. um, Carlson picks up the reins, does that, does what it needs to do after it gathers information from us, turns around and hands it to AutoCAD in the background. AutoCAD goes and does its thing, produces its results, and then Carlson comes back to us and says, okay, there you go. So that's basically that concept. Now, we also talk about where things get stored, as to, and this tells this organizing our work, like where we might keep things. And here is uh, basically that setting. And we'll go over this uh, just briefly when we get into the configuration part here. But we're not going to spend as much time as we do in fundamentals on this. But you basically have three choices as to where you want your data files to live, because all of your data for a particular project that's associated with a given drawing file, um, they all live in these external files. You'll see and be asked for things like a centerline file or a surface file or a coordinate file. Anything that's, part of what we've been doing, a profile file, anything like that, that's part of what we're doing. They're all stored externally. In fact, I've even had a case where I've been working along on a project, and for whatever reason, and I think this only happened once, but anyway, the drawing file itself wound up getting corrupted somehow or another. I lost access to it. I don't remember the details. But all of those data files were still there. And you have commands that will go out and, let's say I wanted to, draw all the contours from a surface as part of my contour mapping, and I just say, well, contour from this external file. It goes out and reads the files and generates the contours. I don't have to go back and regenerate contours as part of that triangulation effort. It goes out and reads the file and does it. If you've accidentally deleted, say, a centerline alignment that's part of your road network, again, you can go out and tell it to open that existing file, draw it, label it, do whatever else. So I basically rebuilt a file from the ground up, starting with nothing, based on the fact that I had all these external files as part of the work. The coordinate files were there. They were able to process field to finish, create all that line work and such again. So it was, really reassuring to have that data sitting there in those external files. Now that marks the difference between the way Carlson organizes things and the way, say, Civil 3D does. Civil 3D makes those into these, what they call extended entities types. So they create new entity types, where you got your simple, points, lines, polylines, circles, arcs, text, blocks, things like that are standard CAD entities. Well, then they have an entity called a surface. They've got an entity called a coordinate point. And they're basically just, regular AutoCAD things just put together and given a little background information. They have entities called feature lines, entities called center lines, called profiles. And they are actually built in and stored with internally as part of the DWG file. So you don't have those things outside of your drawing file. unless you want to export them, particularly for exchanging data with somebody else. So if that drawing file should happen to go down and become corrupted, you're out of luck because all of those things were included in that file. And it's also the case, whereas if somebody's working on a project in Civil 3D and then they have to hand it off to you, who might not be using Civil 3D, you're going to get all of these Civil 3D objects in your drawing file, and your software is not going to know how to use it. Or somebody else might have, maybe they're giving it to another engineering company, and it's in they may also even have Civil 3D, but they have to be running the exact same specific year version of Civil 3D for that file to even be opened. So in that way, Autodesk keeps their customers at the cash register. So um, they have to constantly, keep things upgraded, and forces them into buying Civil 3D whether they want to use it or not. So it's sort of some ambush marketing that that they're engaged in with that. So Carlson doesn't do that. Carlson stores these things externally, much like if anybody's ever used Land Development Desktop, it did that. It works very much the same way that that did in terms of those files. So here then, with this folder model, is where those files are going to live. And the nut of that little conversation is that you can either put it in a project folder structure, like you see over here as part of this picture. Oh, by the way, I always forget to do this until I'm trying to look at where my mouse is. There we go. Now you can see my mouse a little easier. So if you choose this project folder setup, then you're going to be asked to create this list of folders and subfolders that live inside of whatever your project is saved as, is designated. So you open up a new project, all of those directory folders get created for you and placed there as part of that work. So that's a nice way to organize things if you've got multiple offices in particular, so everybody knows where everything is as part of that daily workflow. So they're not just scrambling looking for files. The other option is this middle option for our drawing folder, and that's basically, you can think of that as wherever you saved your drawing file, that's where by default it's going to start looking for those data files, either to save them there or to read from that location to open up one of those files. And again, those are just setting default locations. You're always free to navigate away from those to another place at any time. The last option on the right, which I don't really know of anybody that uses that anymore, but that used to be the only way that that the software worked back in the early days, back when it was only called ServCAD instead of Carlson Survey, because there's now Carlson Civil, Carlson, Point Cloud and construction and trenching and geotech and, all of the different things. So back when it was just called ServCAD, there was a folder called SCAD data, stood for ServCAD data, and that's where every data file from every job that you're possibly working on all went into that folder now. So that capability still exists if you would like to read that, or I mean, if you'd like to set yours up to work that way, then certainly, you know, you would have that capability of doing it. So, and it's just a means of setting your default location for when you go to look for files, okay, and where they get stored. So there's no real best practice there. However, the default condition is to use that default, or the drawing folder, meaning everything sort of follows the DWG file. So that's its default condition on startup. You can change it as you will. And again, part of the book here is going to show you about these data type subfolders. And here's an example of where you have all of these different file types. These are the extensions that you'd see on the file. You assign a subfolder where they're supposed to live. And over on the right is a description of what that file is. And the reason I show you this is that if you don't know, you see a file and you don't know what it is, and it's part of your data set, and you're trying to figure out, where did that file come from? Maybe somebody else created it. Let's look at one right there. It's a CFZ file. What on earth is a CFZ file, you may ask? So a way to find that out is you're going to run your configuration on your settings menu to set this project and project and data file assignment. You're going to temporarily switch it to the project folder list and then go into this assignment. And you can scroll this down. There's, I don't know, 174, 200, and say some number of file types sorted alphabetically by the data type, and you can find there's a .cfz file. Then you can look over in the description. Okay, that's a cut and fill color zone, color map zone. So a CFC, cut fill zone. All right, so that's what that means. All right, so it's even, and then just switch it back to say follow the drawing model if that's what you've been using. So it's a nice little sort of handy trick if you've done, if you're using this default condition under drawing folder, you can switch it temporarily to this, hit this data type subfolders, and scroll that list down that you just saw, this list over here on this page, and find out what those files are. So you're just using it as a means of identifying what those files are, and then just switch it back to what you want. So it's a little bit of a trick. All right, so the next part of your manual here is this section we call, talk about the menus. And we've got general menus versus the modular menus. And by that, I mean those first 7 menus, file, edit, view, draw, inquiry, settings, and points. Those are the general menus, okay? Also including the window menu and the help menu on the far right. And that just basically shows you what each of those things do. And you're familiar enough by now with things like a file menu and an edit menu in standard Windows programming. That's where a lot of those commands live. However, the edit menu, of course, is much fuller than, say, a Microsoft Word edit. It's got more than cut, copy, and paste, undo and redo. So there's all kinds of things that will do. And the draw menu, that allows you to draw basic things. If you need to create polylines, circles, things like that, and some specialized things like shrink wrap boundaries and such like that. And they have very specific Carlson versions of commands that will do the same thing that, say, a standard polyline command in AutoCAD. Carlson has one called Draw 2D Polyline that invokes Carlson's version of it instead of the AutoCAD version. And the big distinguishing feature there, besides some other options on the command line and the startup dialog, is that when it asks you for a point, the same way that the AutoCAD P-line command will ask you to pick a point, or you can type in a coordinate. You just have to know where it is. You can screen click it, or you can type in a coordinate. You can do the same things with Carlson, but you'll see the prompt says pick a point or point number. And that right there is the distinguishing feature between most of these Carlson commands and the AutoCAD commands. Is still at the end of the command, you're left with the exact same entity. They're both polylines, they're both circles, they're both whatever you're creating. But when it asks you for pick a point or point number, you're able to type in the number of a point that's part of your coordinate file that you have associated with the drawing. So it reads those point numbers from that coordinate file, and you can put in a range. You can put, like, go from this point, click to click to click, and now I want to go from point number 5 to point number 10. You would just say 5-10, hit enter on the keyboard, and boom, it connects those points up, and it's still asking for more points. And then you might want to go to point 15, so skipping 11, 12, 13, 14, then you would just type 15, hit enter, it jumps to 15. Then you go to, 37, enter. So it goes around, and then you get to an area where maybe it's okay, I want to go here, but I want to draw it backwards. I don't want to go from 45 to 50. I want to go from 50 to 45. So the ranges are recognized the same way. You type 50-45, and it does exactly that. It recognizes the ranges, it recognizes forward and backward direction, it recognizes numbering if you're using alphanumeric type of point numbering. It can recognize the letters as part of those coordinate point numbers. And so if you have a point 10, a point 10A, a point 10B, and a point 10C, and then you had a point 11, 12, 13, so on. If you wanted to go from, say, 5 to 15, it would go from 5 to 6 to 7 to 8 to 9 to 10 to 10A to 10B to 10C to 11 to 12. So you get the idea. It honors those ranges and lets you have access to what you're doing based on point numbers. You don't have to click where they are. You don't have to type the coordinate value where they are. You don't have to set the snapping to your node uh, value so that it can find the point, the AutoCAD point, if you've already drawn the points in the file. You don't have to do any of that. You're free to if you'd like, but you don't have to. That's the real distinction with that. Okay. So that's the types of things you're going to see on things like this on the draw menu. Those are those type of commands where it creates entities. You're going to see other things. I'm going to jump over here to the next page here on page 9 where it talks about these modular menus. And you see things, and for us in the survey side, we've got picking up after points, we've got survey, COGO, centerline, blah, blah, blah. Now, these menus happen to be very specific to the survey modules. And there are menus, or there are commands within there. Let's say you wanted to draw to draw a center line. Well, you can go to that menu and pull down commands that let you create a center line on the screen using some drawing tools. Or you can also use that to read a file, a centerline file that may have been previously created and saved, and then it reads that file and draws it into your drawing. So maybe it doesn't exist in your drawing yet, so you could get it there instead of trying to figure out how to draw the polyline that centerline file came from. It just reads it and draws it. Same thing, area and layout. That's where you're going to find commands like drawing parking lot designs and features, drawing subdivisions, and it can actually run through an entire subdivision creation process from stem to stern. Um, it's all part of a very sophisticated sort of what you would call it, a read and generate type of a process. Okay, so the draw menu is more for your standard type of drawing entities. Again, they could be specific that you're going to turn into later. And then these other commands, these modular commands, are going to have things that generate very specific other information, other data files, other things that you can read data files and recreate things. Go to the surface menu, pull up the surface menu. Let's say you've already created a surface file or two or three, and you say, okay, now I want to see what the contours from that surface look like. And that's where you would draw those contours. You wouldn't try to sit down and individually draw each contour, not even knowing where they are. You've done the file, it's there, it's going to read it and create it. Okay. We as surveyors spend a lot of time in this points menu and a lot of time in the survey and COGO menu of the modular side. So you'll get, if you're not already, you'll become familiar with that as a process. Okay. So that talks about that. The settings is very briefly talked about here in just a page and a half as to what are governed here, and what controls some of our settings. Up in here is this configure button. We're going to step through that very briefly, just to let you see what the settings are and should be. We're not going to go very deeply into them like we do in the fundamentals class. And then we start talking here on page 11 on these important concepts about points and point groups. So there's going to be some understanding that we need to make sure we know from there. You may be very familiar with them, you may not. and there's some things that we can do. And we'll run through a couple of those little exercises just to illustrate the point. And then there's one of those important notes. You see the little icon. And that's actually I should have put also one of those IntelliCAD or AutoCAD buttons out there as well, because this was a setting that didn't work correctly in the IntelliCAD version. I think they have since resolved that. I haven't tested it lately. And it was very rare and obscure, but anyway, it's there as a little note for you to look at. And then this talks generally about, you know, water points and so here's some let's see, this is still, yeah, points and point groups. So you see you've got half a page discussion there. You got a page here, or another half page really with all the graphics gone, and then another paragraph here as to basically the whole concept behind using Carlson points. And then you start looking at some exercises. Okay, so you can do the same type of thing. They have points and point groups. And then we talk about surface and terrain modeling. All right, and here's your concept up front, a little bit of discussion, what it is, some background, the basics behind how the system works, and some examples of that, and then the process that we go through and what some data sources might be. So we're starting that on page 18, and by the time we get done with looking at the teaching of those things, we're ready to start some exercises on page 25. So you can see just 7 pages, and that's basically boiling down, an entire college semester worth of education into 7 pages in the book. So it doesn't go into the mathematical basis and the rigor of Delaunay's criterion for generating triangles in a triangulation process. You don't need to know that. You're welcome to learn it on your own. It's not part of this training, though, and you won't see it in the book. So, but it gives you enough there that you can really start from nothing and understand what it is that we're doing when we model a terrain, when we model a surface. We're basically creating all the little triangles, uh, they being triangles because it takes 3 points at a minimum to indicate a plane in space. And depending on that triangles, each vertex has an X and a Y and a Z location. And it lies adjacent to another triangle. They share an edge. So in that case, it will lie adjacent to 3 other triangles, each of which also lies adjacent to 3 other triangles. And they're all stitched together and form, say, the fabric, if you will. You can think of it as, my grandmother used to make quilts, and she would go to these quilting bees, and they would all sit together and work on their own little patches and then stitch them all together into a big quilt. That's basically what we're doing. Okay, we're doing that with those triangles. And then some exercises on the effects of break lines. So they've got a bunch of examples in here of what effect they'll have if you do or do not do them correctly. And then that little exercise here is a little sample of and this basically goes from nothing to finished work. You've got a drawing that has a bunch of points in it. It takes you from the point of needing to um, create a CRD, external coordinate file, from the points in the drawing, and then using that to model that little stockpile. And then we design a little, we do some volume computations, and we designed a little borrow pit from that stockpile, and all the tools that we use you can see we're creating surfaces, doing all the triangulation, we're drawing contours from it. Then we design a little access road, we put in a center line. We design a vertical profile, like you see here on the page 55 on the lower half. So that's our roadway profile of that access road. We create a 3D polyline from that, From that data where it gets the horizontal information, the X and Y information, it reads from the centerline file and it reads the Z information from the profile file, and it creates a 3D line. We draw that into our drawing. We offset those two edges to get the outside edges of our pavement surface. And then we run a command that will generate these cut and fill slopes on the sides. We then merge that into this drawing that used to be a stockpile, now has a borrow pit carved out of it, and then we stick an access road into it so that we can get to the site. So it's a nice little exercise. We will not run through that. We might do a couple of things from that, like maybe how to, sync up your data points in your drawing file, but we're not going to go through the whole thing there. But it's there. And again, was part of that fundamentals class. So it's there for your review if you need it. Um, and then we get into these survey specific commands and exercises. And this is where we'll pick that up. So we're going to spend a little bit of time here going over some of the basics inside the software. And then we're going to talk about that. And then the first real and this is these previous things here. These are these adjustments for ServNet and edit process raw file. And again, let me point this out to you in your manual. So we all do surveying now, and I guess mostly it's almost all done with GPS. We have access to that type of equipment, but we still have, total stations and sometimes even theodolites, or in the rare cases, you might have a transit that we use a tape measure in transit. So some way of measuring things, other points that we're going to find a location for. We don't have to rely on the satellites. We do mostly, but if we do any type of uh, set up, backside, turn angle to and measure type of work, what we call traversing, or even just generating side shots, then we have the option of, all of that work can be captured in the field as part of our data collector. We'll get a raw file, and that's going to create this raw file. Now, if you are traversing, you're going to start your traverse by setting up a couple of control points, but you have to tie that into some other already existing point that you know the coordinates for, and really either 2 points or a point and a direction to establish. Then everything else that you create is going to be computed from those positions. Okay, we all know that, I think, is a separate function of what happens when we traverse. Now, so these adjustments are, and it talks about why do we adjust our measurements, okay? And the reason for that is right in here, is that if you don't do that, because here's what we usually come up with, and I've had owners of surveying companies tell me this. It says, so we said, why are we spending any time adjusting our measurements? He said, because we've got high quality equipment, and if my guys came in out of the field and did work that was so shoddy that it had to be adjusted, I'd send them, I'd fire them, or I'd send them back out, at least to get the work done a little tighter. Okay. But here's what happens is that when you're doing this as work, where you compute 1 point based on a previous occupation that was previously computed from a previous to that type of occupation, you're not, and the system always has a little bit of error in it. It can be user error, like where you mispoint to a target, or you can miscenter over a point location on your tripod, or your instrumentation might have a slight bit of error in it so that it reads all distances just slightly longer, or maybe, you get the idea. So there are random errors and there are systematic errors that are part of that work. Now we get to the end of our traverse and we find out we've got a closure of, say, 1 part in 20,000. Well, that used to be good enough for us way back in the day before all the electronics. And we would just say thank you very much and go on about our business. But here's what happens and why I would say if you're doing traversing in particular, make sure you adjust the data because it's not averaging all of those things as we go along. It is computing raw position based on previous raw position based on previous raw position, and all of those carry with it certain amounts of either user created random errors or a systematic error that would basically skew everything in one direction constantly. And when we get to the end, if we're not going to adjust this stuff, we're saying, okay, all the measurements before we're going to rely on and keep their results. And we're going to say all of the error then goes into this last little observation, this last little leg that we closed the angle and shot a distance back to the command or back to the control network. And so we're saying, okay, everything else is good except for this last button, this last point. And that's not very mathematically rigorous. However, like I said, with a nod to the practical, it really is, our equipment is good enough to get decent working positional placements, but you will actually shift those computed coordinates a little bit if you balance the raw file, if you edit and process that and balance the traverse work, do the adjustment on it. All right, so school of thought on that, if you're using traversing type commands, then compass rule adjustment, which works on those, is basically the same thing as a least squares adjustment with all unit weighting. Everything's weighted as ones. So a lot of the terms fall out of the equations and you're left with a standard, adjustment type of algorithm. The least squares adjustment, however, is a bit more mathematically rigorous, and it computes things and takes into account different weightings. So maybe you're saying that, okay, my instrument reads angles much more precisely than it does distances. And then you would set those up and it calculates using differential weighting of those areas, of those observations. So that's there, and that gets into a lot of number theory and a lot of adjustments. Again, we talked about the C&G stuff. So there is an exercise in our book that goes through all of those types of least squares adjustment processing. And we probably won't have time to go into much about that. I can show you where that is, and we'll leave those and the exercises, for you to pick up on your own. But want you to see that they're there. That's why they're there, is to do that type of adjustment, whether it's least squares or whether it's those other more traditional traverse adjustment type tools. Now, the other thing, if it is all done as GPS observations, you can actually also adjust your GPS saved data because you're basically adjusting these vectors that arrive at your point position from a position in outer space where that satellite sits, and it's going to, compute your position. Now, most of us in practice probably subscribe to an adjustment broadcast service. So everything's automatically adjusted anyway, and you're getting the corrections by broadcast to your instrument at the time that you measure the software. But let's say you don't, and you're just recording raw GPS data, well, you can have this do a similar type adjustment, and it's always least squares in that case, but it can adjust GPS vectors as part of that networking adjustment. So again, it gets into a lot of numerical theory, and for the type of work that we're doing, not anything that we need to lose any sleep over. But if you're, working for the National Geodetic Survey, uh, the government agency that controls all of those control networks across the continent, then, you might, and you're doing a lot of geodesy work, well, then somebody somewhere is taking a look at how those observations are adjusted. And, they're the experts, so we're going to leave that to them. So anyway, That's the deal. But the one thing I want to point out was the fact that if you're not going to adjust your traversing data, then you're saying that you're willing to accept those raw positional points, except for the last one, and all the area gets lumped into that last observation. So anyway, that's that. Here's your different adjustment methods. So it talks about these, and we'll have a couple of little exercises. The other thing that we want to talk about when we get there, do an example, is this is what's called a raw file. And you can think of that as the tape recording of your work out in the field. So you see there's records here on the side that says point and backsite. So you're establishing a point. You're creating a backsite by sitting on that point and looking either at another point or a direction. In this case, we've got an azimuth that we're setting. And, and then you create by means of these, I'll say TR. So I've traversed through. So I set on point number 1, which is also here at 5. And I created point number 2, number 3, number 4, and number 5, and then closed back to this point number 99 as my angle close point. So that's basically the computational path to those point locations. Okay. And we can, look at that as if we're out there on the ground, or perhaps this actually did come out of a data collector, and those are actual ground observations. The other thing to know about raw files is that when you compute points back in the office, just using coordinate geometry commands from the COGO menu, those commands are, if you're familiar with COGO type computation, you'll know they're familiar with the way we survey. You basically tell it an occupied point, a backsite point, and you turn an angle and you go a distance, and that creates the next point. And if you're in traversing mode, it steps you up to the next point and moves the backsite to the point you just left. If you're in side shot mode, it keeps your setup where it is and just computes point after point after point until you traverse off of it. So it records all that into a raw file. Optionally, you don't have to, but you can turn that recording on. And then later on, let's say maybe you calculated hundreds of different point locations, and you found out, well, gosh, what happened here? Oh man, I must have typed in, instead of 45 degrees, I typed in 54 degrees. Okay, so something happened, or maybe you typed in, 445 degrees, 445 degrees. It did its own little math, took the 360s out of it and calculated what it was. And then every point from that point forward in the rest of your design of your work is now wrong because you entered a particular setting. So your raw file, if you have that saved, you're able to go back and edit that one, bad uh, angle that you typed in. And there's nothing magic that's going to help you find out where that might be. There's a couple of tricks that we'll talk about, but um, anyway, nothing. There's no magic button that identifies those. So anyway, you could go back in though and say change it from 54 degrees back to 45 degrees, and then just reprocess the raw file, and it recomputes all of those other points and pulls them right back into where they're supposed to be. Okay, so that's the advantage of raw file processing, more so even than adjusting the actual control network, is that it gives us an audit trail of our COGO computations that we can edit and reapply any changes at any given point. Okay, so we have sort of a running history of how those points were calculated. We might even see one that we decide that, I didn't even need that pointer. These are 5 points. You might decide to take those computations completely out of the raw file, reprocess it. So you basically would never generate those points again if you reran the raw file. All right. So that's what we'll take a look at, is some of that simple editing and balancing of that stuff. And then, like I said, there's some other examples over here, is like a real data set that came in from, a coordinate project, or a surveying project. And shows some examples of what that work was done. And then ServNet, this is your least squares adjustments. At least, the Carlson ServNet talks about what it does. There's some procedures, the interface as well. And again, it's a bit more sophistication on that raw file processing, and it's meant to process our traversing work more so than anything else. Um, and it can work on any of those aforementioned raw file types, whether it's a audit trail of a COGO computation setting or computation session, or if it's a result from field observations. It's usually from field observations, but this will help balance all that stuff out. All right, and then we're going to, at that point, pick up, here's our real first um, quote survey type command or workflow that we're going to jump into is field to finish. And that will be, sometime after lunch today, we'll get a chance to head into that. And that's going to be some real important things to sort of grapple with. So that's our roadmap through here. And then we'll, just continue through some of those. We're going to lightly touch what we need on the upfront parts, um, particularly from the fundamental side that are covered in the fundamentals class. Again, you won't have a lot of coverage here, but that is where it is and what we'll talk about when we get to it, so you'll know where those things are. Okay, so right now gives us a good spot to stop for our mid-morning break. We're going to come back with we'll give you your 15 minutes here. So um, we're about 5 minutes past where the real actual midpoint is, but take your full 15. So we're going to come back at 10 minutes to the hour and give you a chance to stretch your legs, get another cup of coffee, answer some emails, do whatever you need. But before we go, does anybody think of any questions? Has anybody, um, you know, aha, I just thought of this, maybe we should find out. Um, so if we're all good, then I'll see everybody back uh, at 10 minutes of. All right. And oh, by the way, I will stop the share. So you'll see the share go away. And when we come back, you'll see that pop back up, and then we'll go from there. So I'm gonna mute Scott. I see yours is unmuted. I just muted yours. So now we're all muted. You guys are. I'll mute myself, and then we'll come back at 10 minutes till. All right. See you then. And we'll pick up from there. So the again, the book is structured like you see there. Looked at the menu sets. There's an upfront part that covers the more fundamental or basic parts of the software, and then the survey part itself as the follow-up. So that's where we'll jump. So right now, what I want to do is take a quick look at some settings. We won't spend more than about 10 or 15 minutes on this. And Scott and Sarah, you probably sighing a great sigh of relief because we really delved into the settings and what they control as part of that fundamentals class. So you've got that good bone deep understanding of it. The others of you, I'll point you toward, uh, you know, learning about it through Carlson's help system and just practical experience. So to get things started, let's go ahead and open up a file, and I'm going to use the AutoCAD version since most of you are running on that. I think I managed to catch the double click. Maybe I missed it. Yeah, there it is. So when that comes up, you may get this little startup wizard, which is another way of helping you find previous files and all of that. But the primary launching pad, if you will, for it is going to be the start menu, or what's called the start menu. And you may or may not see this because It could be, let me maximize that. There we go. It could be that your installation is configured so it doesn't use this. You don't have to use this. It's just a convenient little way of keeping track of recent files. You can see them, by list, by details. You can sort by date or when it was last opened. You get little connection information over here. All these down here on the lower left-hand corner, you have access to those. These are all available either just from general internet searches or also from the help menu inside Carlson itself. You have these other categories here on the left that you have things like just My Insights. The AutoCAD will track your usage, and every now and then you get an email that says, hey, we noticed you do this command a lot, and we think you can improve by doing this other type of workflow kind of stuff. There's some insights. That's what they call their insights. Here's your usage details on what you typically do. I've got open and saved drawings. Looks like that was the biggest part of it. I've got object modification, 15% and 13 of navigation, 70% of you can follow that. It's not rocket science. You have this learning tab, and this is really helpful. If nobody's used this before, these are excellent little tutorials on doing specific little things, and you see it's a scrolling list. You can go through these, and so some of these are videos, some of them are just little pop-up windows that tell you about it. But excellent little ways of learning a little more deeply the AutoCAD, the base underlying product that you're using. Okay, so we're going to keep this on our recent files. And we would start things and stop them from here if we are keeping a list of recent files that we've been working on. So we'll go from either, if you're not at this screen, don't worry, just go to the file menu or the little control buttons at the top, and let's make a new file. And when we make a new file from here, it's going to jump into this startup wizard that you're going to see showing here on the screen. And when this pops up here, I've got a list of these recent files, again, just like the startup page. But you got the buttons down here below, and there's this little checkbox that says skip the startup wizard next time. If you don't want to step through all this stuff, you can do that. But let's make a new file. Even though we're sitting in a new file, we could just exit and do a save as, but to see what the wizard does for us, let's choose that new file button. And it's going to basically generate that new file, which it already did, or it's getting ready to. And right now it's asking me to select a template. I need to choose a template that is basically it's a drawing file, but instead of a DWG, it's a DWT, and it holds a lot of my settings like layer definitions, line styles, text styles, certain system variables, that sort of thing. It can also have like entire things pre-drawn and pre-built. I can have a bunch of layout tabs that hold things like title bars at different page sizes and all that. So it's basically a getting started document, just like a Microsoft Word template would be or something of the sort. So we could let's use this, there's a Carlson National CAD Standards. There's based on civil. There's all these other AutoCAD ones. There's just a number, and they can be from anywhere. You see, it comes out of MapBook because this was running originally on top of either Civil 3D or AutoCAD Map, one or the other. And then you got these different architectural manufacturing and then metric architectural manufacturing AutoCAD examples. So I'm just going to come up here to start at the top, and I'm just going to choose the basic there's one called Carlson 24, even though I'm running the 2025. Let's just choose that one. And it doesn't matter for what we're doing. You can choose anything you want. So once that's done, it's loaded that startup template, and that sets my layers and things like that. And it's going to ask me to fill out this information about this product that I'm going to, about this file that I'm going to create at this point. Again, there's your skip startup wizard next time if you want to turn it off. Notice, because I ran through the wizard after I got things started from the start page, which created that drawing one for me without the wizard, and it launched into this, and that generated the second one, which is now called, by extension of the original, drawing two. So those are two drawings that I now actually have open, and we'll close off the one, save this other one. Once we give it a name, it's going to rename that drawing two. So, and this is one of the reasons I like using the startup wizard, is that we're going to set some of the things about it here. English as our units, 1 inch equals so many feet. We're going to give it a horizontal scale. I'm going to set this, instead of a 20, I'm going to set it to a 30. Now keep your eyes right there on these drawing unit numbers. Based on whatever number I type here, those change because it's reading this over here. These are my desired plot symbol size and my text plot size. Think of that in terms of plotted inches. If I make a drawing at 100 scale and I plot that on paper, that's how big those symbols will be and how big the text will be just by default. So I'm going to say make this a 30 scale. So that means 1/10 of an inch at 30, at 1 inch equals 30 feet, will be 3 feet tall for my drawing units. I don't have to tell Carlson what my drawing units are. I don't have to do that little mental math. Carlson's doing it for me based on this right here. And then I'm going to give it a coordinate system, and it can either be none, in which case that all goes away and it's just local assumed coordinates, or I can be on any of these others, a predefined or user-defined system. And then they've got state plane 27 and UTM as also predefined systems. That really all should be under this, because you can still access those from here. I don't know why they give you those. So if I choose like NAD 27, then I can choose whatever state I'm in from here. If I choose UTM, then I can choose whatever UTM zone. I think we're in 17 here, Kimberly, if I recall correctly. But we're going to use this user predefined, but we can't pull this zone down now and find it, because it may not be a state plane zone. It will be though, but we now go to the define projection button. And you notice right now mine comes up with this one for Alabama East. And that's because it's the first item. When I choose that button, that was the one that it was sitting on last when I last ran the command, I suppose. It doesn't read the first one unless it's sorting them by alphabetical or something. So what I would do is look for the area that I'm in. I happen to be in NAD 83, Pennsylvania South. Well, let's suppose I'm doing this in West Virginia. And notice my list of choices here is very limited. It's to whatever I have chosen in this box. So I'm going to add a predefined. Let's say I'm working in Morgantown. Here's your various regions around the world. You got specific counties and states, or USA in general, and other countries as well. And then in search, I'm just going to start typing West Virginia, good enough to make it unique. So here's all my West Virginias. So let's say I'm in the north. I'm up here in Morgantown. There's my NAD 83, the 1986 adjustment, or I'm on the NAD 83 2011 adjustment, or the HARN adjustment, the high accuracy reference network. Whatever you're needing to set your coordinates to, you're going to choose that. I'm going to choose the 2011. I'll say okay. It now becomes part of this list, and that list will stay. The next time you run it, it will now be available from this list. So I'll say okay, and then you'll see that gets populated down here to the right of that. The project name will be Carlson Survey Class. The job number is 123-ABC, whatever it wants to be, and the location would be, I'm here in Pittsburgh, PA, even though I'm in West Virginia, the project. So these fields right here, and I very rarely actually use them. The only thing they're used for in the software is to put headings on your reports when you run them. So then if you were to print reports or publish reports, all of this information goes with that particular report that you run. And a report is anything like list points or uh, list horizontal alignment data, any, volume calculations, any of those kind of things that give you a text output becomes a report. Okay. So now you're going to see next the real reason I like using um, the startup wizard. If I say next at this point, it's going to say, hey, you didn't tell me a drawing name. Aha, because it's very easy to blow past this and start doing the setup without doing this. So it tells me now my default drawing folder is Carlson project based on some of my startup configuration, a new drawing name. So what I'm going to do is say, okay, I need to come up here for drawing name and give it a name. And if I want to keep it in Carlson projects, I just type a name, but I hit the set button and it lets me now go out and navigate to find the location I want to put this file in. Now this is Carlson's file dialog box. It's available for any of the files that you get, that you're asked to either save or open. And sometimes you'll see a tab up here at the top. It'll say new or existing. And then occasionally you'll see one that says append. So in other words, you'll pick a file that you want to append to. Um, so they're pretty self-explanatory there. You got a folder location. You can pull this down and it keeps track of previous folders you've been in, or you can choose a specific folder. Now, if you don't like using this dialog box, you always have this browse button, and that puts you in the Windows dialog box that you're all familiar with. You can scroll to different folders. Same thing, pull this down. You've got a save as type down here where you can choose, and then you can give a particular file name that's in a particular location, or scroll down and find it and double click it, etc. Typical Windows file open dialog. Now in the Carlson dialog, one of the things I do like about it is that if you're looking at things like a coordinate file, you'll get a extra little window down here and it shows you a preview of what's in that file. For coordinates, it will tell you, how many points you have in there, what your point number range, date and time it was created, that kind of stuff. But here's your basics of what this dialog has. We have the current folder files right here. You see the little title there. We have the recent files down here. Now this is regardless of which folder you're sitting in up here. This shows you just a list of recent files that you've been working on. You can pick it from there. Sometimes it's a smaller list than you'll see up here. This window over here shows you the subfolders within the particular folder you're looking at. So if I went to, let's see, here's a folder. A lot of those are on my work. Let's say I was here in this particular folder. Now see, there are no subfolders in it. Here's a bunch of files. Okay, so it just recognizes where you are and gives you that information. The so I like to use this particular one primarily for when we look at these other files. It's going to give you a preview. You're going to look for if you choose a surface file, it's going to show you either the outline of the surface if it's too large to display it, or it will actually shade in the surface for you and show you that entire surface. If you choose a centerline file, you'll see a picture of the center line. If you see a profile file, same thing, you'll see a picture of the profile. So it's a nice little way to verify that you're at the right particular file. Now the file up here at the top, the files of type, right up there, the drawing to create DWG, that tells you what type it's looking for. In this case, since there is no choice, you can't change that. When you have a choice for other file types, like maybe a text file or a comma delimited file, things like that, you'll see the different extensions that it will allow that you choose. Okay, so that's sort of the corollary between that and the Windows file picker. You choose either one. sit in the folder, type the name, or since I don't have this in my recent folders list, I'm going to look at my subfolders, and I've actually created one here with my data sets in it called 2025-0911 Survey Training. So I'm going to double click inside of that, and I could either just put it in that level, or I've actually got two subfolders in here. I've got one which is my field to finish uh, guide, or quick start and training guide, or my data sets for my survey class. So I want to be in my data sets. I'm going to double click that. And now these are the files that are already existing here. Now, a couple of notes about these files that you see. In this dialog box, you'll probably see a bunch of these files that start with a period and an underscore. Notice they're all the same file size. Those are little individual, they're normally hidden files. The um, the Carlson dialog box ignores whether you've got your hidden file switch turned off. The Windows dialog box does not. You would not see that. But you'll see those in here with this particular data set for this reason. All of these things were produced on a Macintosh computer. I'm running on a Mac right now. I'm running Windows as a separate program. It's called Parallels, and it actually runs Windows as a program on my Mac. And so these are just files that correspond with these other real files that you'll see on down below once you're past those. So any file name you see with a dot underscore as a leading character, you can ignore. They had no effect. They will not give you any results. Down here are individual files you can choose that are existing there, but we're going to come up here and actually type our file name. I've got my folder set. I'm not going to type it. I'm just going to call this sample. Let me put my uppercase on. We'll call it sample work file, something like that. Now, you can type .dwg or just leave it alone. It will put it on there for you. So I'm going to create that file. And now that fills out where it's going to go with the full folder and my default drawing. My default drawing folder is still Carlson Projects, but this is now where I'm going to choose. I'm going to say next. Okay, so now it goes to the next point in the wizard, which is basically says, okay, here's your file. I've created it. Notice up here at the top in my tabs, it tells me the file name. And if you look at this top strip across the entire top of the application, it tells me what software I'm running, and it tells me a CRD file is set to none right now. And then it shows you the drawing name. Okay. So right here, because it says none, I need to associate a coordinate file with this. Now, you don't have to. You can do plenty of work in Carlson without ever using a point file, a coordinate file, but we typically do as part of our work, which is why it's part of the wizard. And you can again set the data path. Now notice the data path is now changed to my data sets for survey class, and it wants to know a coordinate file. And right now it is just offering one of the exact same name as the drawing file name. And if you did that, it would create that file, or it would open it if it already existed. If you choose set, it's going to come up here and ask you, now here's where you get the little difference in the dialog here. If you choose set, it's going to look for a particular file. And let's say if I wanted to use that one, you see my little preview, it tells me I've got a point range. I've got 4 points from 1 to 4. I've got, here's 1 to 1106, but there's only 16 points in it. Here's one that's got 1 to 144, and it's got 144 points in it, job number and date, etc. So that lets you choose it. Now, if you choose this as existing, then that would open that file. If you said new, and this is where I want to point this out because you need to be careful here. And then notice your extensions can read CRD, CRDB, and GC or CGC. So that's a CRD format, which is a typical default for Carlson. It's a CRDB, which is a special format for Carlson. It's an actual database file. that can hold additional data in it, like GIS information, if you track that and get your GIS attributes. Um, or it can be a CNG coordinate file, CGC. So if you were to be sitting on the new tab, however, and then you choose one of these, when you say open, I don't even remember if it prompts you for it or not. It will actually overwrite this file name if you choose one that already exists. Okay, so make sure you go to existing or you type new. And if you did new at that point, you can give it a new name, that sort of thing. I'm going to hit cancel so that it just keeps this sample work file .crd as the file to choose. Now, the next step in that process of using a coordinate file might be to import points from these sources: data collector, from a text or ASCII file, from, it says current CRD file, which is really unfortunately named. It doesn't mean the current file, i.e. the file that you just told it about up top. It means from a currently existing file. So it should say existing CRD file. It shouldn't say current, but that's what it means. Or we can say none. Now, if we chose these particular ones, it goes into the import points routine that we could then load this file right as part of this wizard as we get started. The import points routine, again, can be done from a command on the points menu. All of these commands in the wizard can be done from different commands. So I'm going to say none, so no import. It will stay empty, and I'll hit next. And at that point, it's going to go out and put me in my drawing, which I'm already sitting in here, and it's changed the file name. Okay, so it's there. And I can go back here to this drawing one on that tab and just click the X button to close that one. I don't need that one anymore. So there it is. I can also switch back to my start page and come back up here. Now, if you're not using the start page and you want to, there is a command called start mode, I think is, see, what do I have? I've got start, see field start. Let me see, the question mark. The start command, normally it puts you at that the start tab, for instance. It's been redesigned and consistent, blah, 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 about the start tab. Get out of here. Open the select file. The start tab contains to display or hide the start tab. So right here, you would set this command, this variable called start mode, either 0 or 1, and then you have to restart AutoCAD for it to be displayed. But you would type that start mode and put that value in there. To display or hide it, you say at the command prompt, you would type start mode, enter 1 to display or 0 to hide. Okay, tells you have to restart it. So that's a way to figure out that and configure a couple of things. Now, about the interface and what you see on my screen versus what you may see on your screen. You may see something like this. I don't have the option here, so I have to know what the command is. And in IntelliCAD, if you click up here, you'll see a choice to use the ribbon or use the menu bar. So we're going to, I think it's not even available here. No. So if you see yours and you've got your ribbon interface, you've got this command in AutoCAD, not start ribbon, but ribbon. And you see my choices are, I can use ribbon, I can load a specific ribbon, or if I just hit ribbon, it's going to turn on my ribbon interface. It's going to ask me, let's see, sure, whatever I bring it is. And so now you're going to have this ribbon interface up here, and I'm going to say, I don't want to actually, Yeah, I want to turn it on like that. So you may see this, and this is your typical uh, ribbon interface. Why is it not switching here? There we go. It's finally catching up to me. So that's going to switch you back and forth to these individual ribbons. Now, that's all well and good if you like using ribbons, uh, and so they're going to sort of group commands based on those particular type of things. Here's your setup. Let you switch to the different Carlson modules. There's your drawing setup. Here's your drafting. This is where you create a bunch of things. There's your points. There's a survey somewhere, I thought. There's surface. Ah, you know why? Is because I'm in my civil workflow up here. So if I switch to survey, that's going to switch. Now I'm going to have a survey tab. And on that particular tab, I see things like field to finish and all of these different things. So that's all good. I don't particularly care to use the ribbons. So I type my ribbon close, and that gives me that much more graphic space. And I do all of my stuff with um, my typical um, toolbar layouts and stuff like that. Now, right now, it's pretty meager because I've switched workspaces, and I'm looking for where I can set my workspace back. Survey, let's go back to civil. And then if I ribbon close, my ribbons go away. Here's my toolbar layout that I typically use. Now, I'm in civil right now, which no, still in survey, even though my workspace is set to civil. Apparently I'd switched modules. There's survey, there's civil, but it's not switching the workspace, so that's why it's contained there. But anyway, if you want to set those up in these separate workspaces. In fact, I could rename this instead of civil. I could rename this as, give it my name or whatever I want to call it. All right, so that's just standard type of layouts for the interface. I've got a bunch of toolbars here. We'll talk about them as we get to them and a couple of our features here. But if you notice, I put the mouse over here on the left, on that little strip right there. That's actually my layers control, okay? And I just leave it on the left. I have not allowed it to dock, so it won't snap over there and lock, but I do have it set to auto hide. So when I move off of it, it goes away. When I move onto it, I'm just hovering the mouse, it pops it up. The same thing is over here. I do a lot of work with external reference files, so I keep that over here and float it on the side. And I usually kind of sort of tuck it over here to the side so it gets out of the way. Okay. I've got a bunch of different toolbars here. One of which I have out here is my object snapping. And normally I would bring it up here and dock it here at the top. And that lets me override some of my current snaps, which you can also control from the status bar down here, or you can set your settings. I normally keep endpoint, midpoint, center, and extension running at all times. And so those would be the ones that are in effect. This toolbar up here lets you, in the middle of a command, when it's asking you to pick a point, you can override those and choose one of these which works just for that next mouse click. Okay. So if I needed to snap something perpendicular to something else, I would come up here and choose that perpendicular icon, even though it's not turned on in my general settings, my general snap settings. Okay. So that's what I have with mine. And we have now a series of menus that we're going to be pulling our commands from mostly so that you know where they live. But once you get into your production work, you're going to probably take it from the ribbon or from a toolbar once you know where those locations are. And here's a couple of things uh, to help you figure out where things are. There's a particular command that I use quite a lot of, and it's under the Edit menu, and it's Polyline Utilities. I'm down at the bottom now, and I pull right, and I get a bunch of menus and things here that I can do, and I'm going to look at this Remove Polyline. These are not erase the polyline, but remove from a polyline certain things, and I can remove any duplicates, any arcs, and replace it with a series of segmented chords. Or I can remove a polyline segment or remove a polyline vertex. That's one I use all the time. Remove that polyline vertex. It's much, much faster than using AutoCAD's built-in polyline edit command, the p-edit command. And it's much more intuitive. So what I want to point out with this, seeing where this is, that's a command I use quite often. And I see that I have to go to the Edit menu, click, come down to Polyline Utilities, pull right, come down to Remove Polyline, pull right, and then finally get to the command. Well, that's not all that efficient to have to do that every time. So if I see one of these commands that I use a lot and it has an icon to the left of it, that tells me it's on a toolbar somewhere. It doesn't tell me which toolbar. It happens to be on my Polylines toolbar, which is up here at this top here in the same icon, a little pencil eraser hovering over a red dot on a polyline is what you see up here in my Polyline toolbar. That's where I usually pull that from. You can also type the command, which is RMVERTEX, or you can set up a shortcut to like RV to make it do the same thing. But if you see an icon there, know that it's on a toolbar somewhere. And if it's something and you don't know which toolbar and you're wondering where it is, there's another command for that on the help system, on the help menu. And it's called command search right here. So if you choose that, you're going to get this. And these are like all the commands. If you scroll this list down, you see it's quite extensive. Okay. But you can just type what it is. Let's just say vertex. So anything that works with vertex, there's remove polyline vertex right there. And I see that that's the name of the command. It's on the main menu of edit. It's on a submenu called remove polyline. It's available to all modules. So if it's, a civil command and you don't have the civil module, you would see it listed. And maybe it'll say civil, comma, construction, comma, or civil, comma, geotech, or something like that. It tells you the typed name of the command. There it is, RMVERTEX. And then it tells you what toolbar it's on. It's on the Polylines toolbar. Okay, so you would expect that under Vertex. If you just type, for instance, draw, well, there's all kinds of different draw commands. Looks like they're all available. And here's one that's survey and civil only, for instance, like draw a north arrow. Available to that, and it's on the annotate. Let me open this up a little further. Annotate general toolbar. Okay, so that tells you where those things are located. You can either run the command from here, get help on it. Okay, so that's a nice little interface for you there. Similar things for the AutoCAD command is up here in the top. You can just type, if I wanted to say like p-edit, my polyline edit command, and if I choose that, it jumps me and tells me what it is. I could then execute it from there. So there's all kinds of ways that you can, let's see, click there to access help. That's also available in the help menu. So anyway, there's all kinds of ways to find what you're looking for. If I type p-edit and hit that little command there again, it shows you where it is and you can execute it from within all of that. Okay. So that's a way to help you as you're learning and to see where things are and what they do. Now, which particular toolbars that you might want to have out and about and show you where they are. And again, I've got my layer properties palette, which is this one I hover over. I've got my properties palette, which is here on the left, and it stays permanently docked. So I'll right click in that little title and I said allow docking. So it's now docked on the side, and it can dock to left, right, top, or bottom. Um, and if you were to just grab that and pull it out, you see it floats. And now I can right click and choose allow docking, or I can anchor it to the left or to the right. If I say allow docking, if I pull it down, well, it's not going to allow me to dock over there. It'll dock there, won't there, it'll dock there. And you could also choose to uh, auto hide, just like this one does. When I hover over my layers, it pops out, this flies out. But if I don't um, do auto hide and I anchor it to the left, where was it? Here. I want to take off the auto hide. That's what I want to keep it there. So the reason I do it that way is so that I don't have to constantly come over and hover to get it to pop out. If I see something in the drawing, and let's just draw a circle. All right, so I've got something here drawn. Now, if I select it, the properties of that item show up in that properties palette over there. So I can see what they are without having to go over there and fly it open. It's going to stay showing me here, and I can look at various things. If I also draw a uh, polyline, I now have a polyline. It's got certain things about it: color, layer, line style. I've got if I choose that, it's things that are common to that thing that I select. In fact, if you select both, I'm going to click and drag to the left to do a crossing selection. I now have two items selected. I look up here my properties and I see the count of the number I've got selected. I've got all two items, and I pull this down and I choose individual ones. So if I leave it on all, it lets me see all of the characteristics of those items, all the properties that they share, that they each have in common. They each have a color, they each have a layer, they each have a line type. I can set them both to be, if I wanted them both to be red instead of by layer, okay, you can make them, that specific type thing. Or if you want to work on just the polyline, I'm going to pull that down and set this one. And even though they're still selected, I'm just working on the polyline. And now I'll put that to a separate layer for it. I'll make that one yellow. And that's the way the properties work. And I'm going to set, and you can do that to set things like elevations, all kinds of ways that you can set things, set properties of different things through that palette. All right, so I'm going to just select that stuff and delete them, just get them out of my drawing. So here are the toolbars and how you can set these up and share them back and forth in different ways is on our settings menu. We have a toolbar manager, which lets you load and save particular toolbar settings that you've set up, or you can set by a particular program. If I load by a program, it looks at maybe a previous installation that I have of the software. I can choose it, and it would load up that set of toolbars from there. If I, obviously you can save the one you've got currently now and then load them up. So it'll let you pick from pre-configured, or we can go to this, in the IntelliCAD version, there's also a toolbar settings, which lets you pick from that. I don't see if this configure interface. Nope, that's more configuring. But there's also another way is if I click up here in the empty gray space and I choose these particular programs. So I'm running AutoCAD, so these are all of my AutoCAD toolbars that are available to me. These are my Carlson toolbars that I'm available to me. This is my Express menu, which you may or may not have loaded in your system. And that you can load by a command called Express Tools, one word, EXPRESSTOOLS. And it gives you, a couple of things there. Um, and then you've got these, you can lock the locations of what you've got set up. And then you've got the customize button, which brings you up this almost programming level means of customizing your interface. All right, so we'll skip out of that. So that's a way to bring these particular toolbars up. You just right click, you choose the uh, configuration. So here's the ones that I have on mine. I've got a few AutoCAD toolbars. I've got the AutoCAD Draw toolbar, and that's this one on the left here vertically, just to the right of my properties, and it's the first one there. And those are the draw tools available from AutoCAD. I also have, if I look over here under Carlson, you see I've got a draw, parentheses, Carlson. So that's a separate draw toolbar named the same, but it sits over here right next to the other one. And that's one I use more often than not. So then back to AutoCAD, I also then have layers, which that's my layers palette over here that flies out when I hover. And there's a layers 2 toolbar, which lets you do things like a layer walk and investigate things back and forth. I've got my modify commands, and these are my standard modification commands over here on the right vertically. And I have object snap, which that's this toolbar up here that I docked that I don't typically use. I use a shortcut holding the shift key and right clicking the mouse, but that's there for illustration purposes. Then I've got properties. Again, there's my properties. Another way to set your properties is just come out here into the empty space, right click. Well, no, not for that. I need to have something drawn. So if I draw something there, and then if I right click that, select it, right click, I can choose properties. So if it's not showing, it will pop the properties up for that for you. Mine was showing, so it had no effect. All right. So, um, again, there's the ones that I have. I got draw, layers, modify, snap, properties, then standard, which is this toolbar here, upper left, or it's horizontal. It's the first one all the way to the left on the first row. That's my new, open, save, print, etc. It has undo and redo as part of it as well. All right, and then my styles, which I don't see offhand where it was. Let's see. Turn it back on, see where. All right, styles, it's called styles. It's called entity properties in IntelliCAD, I think, or in Carlson. Yeah, in IntelliCAD it would be properties. So now on the, let's see, anything else under here? I've got styles and that's it. Okay, so for my Carlson toolbars, I have all my Carlson menus, and that's this one here on the left horizontally, all the way to the left third row. That lets me switch between the various modules. I've got my Carlson draw tools, which is vertical draw over here. So I have draw on the left, modify on the right. I have grading, which is a toolbar up here behind the screen here that lets me set some 3D information about certain objects. I've got inquiry, which is this little toolbar here, and really the only command that I use out of there, or predominantly more than anything else, is that standard distance command. It lets me compute what distances are when I pick between points. Layers. Notice this is Carlson because I have layers already for AutoCAD. It's sitting out there, but Carlson has a layers toolbar, which is this one right up here. And it has things that I can isolate and restore, freeze and thaw, turn everything on and off. Then I have erase by layer, which is on the edit menu, whereas these others on the view menu. And then set current, or pick a point. There's all these different commands that you can choose from that toolbar. Very handy to have. And I've got my polylines toolbar. That's a tremendous time saver of doing the edits because you don't have to dig way deep in the edit menu. They're all there for you in one spot. I've got the surface toolbar, which is this one middle horizontally on the left, which lets me do things like triangulate and contour. I can view my drawing 3D information and view my drawing surface. Those are the three that I use mostly out of there, but all those other commands are available as well. And then my transparent point or selection commands is this last vertical one that's tucked underneath in the same vertical column as my modify tools. And that lets me, in the middle of a command, when it's asking me for a point, I can use those things like a bearing intersection, or pick the centroid of a shape, or a bearing distance, distance. Pick the elevation of something to supply the z coordinate value. All these different types of things that work in the middle of other commands. Those are called transparent commands. All right, so that's what I have out there on mine. And if you have the IntelliCAD version, you'll see some other things that will say like Carlson DGN. And you'll see Carlson, you'll also see Carlson DGN, because Carlson's IntelliCAD version, at least, will open, read, and write MicroStation files directly without translation. Um, this version, the AutoCAD version, should do that as well, but it's not as robust as the IntelliCAD version. And that's basically because of the lack of that rigor in the AutoCAD basic engine as opposed to an IntelliCAD basic engine, because this version of IntelliCAD was mostly written by a consortium of all kinds of programmers all over the world, but a lot of the stuff in it Carlson programmers wrote, and they spent a year with the programmers at Bentley to get that DGN interface really robust. And in fact, when I'm working on things back and forth between the two different platforms, I don't even have to go to, open this, convert that, save as. I just open a DGN file directly and work on it, and then can go back into MicroStation and open that file again with any changes I've made using Carlson tools. And I do have to do that on occasion. So that's sort of the whirlwind tour of our interface and how it works. You should have a command line at the bottom. And I will tell you this, when you are setting up your command line, see, this can be expanded and show you a certain number of lines ahead. I like to set this to where you can see at least 3 lines above the actual command line itself. And there's a little pull down from there, and you can choose these particular previous commands from there. You can also right click the mouse. You got recent commands here as well. So, but I like these 3 lines above, because when it asks you to do something, at this point at the command prompt, it's going to ask you to, maybe it'll say select entities. Well, what is it that it's asking you to select? In particular, for, let's say we're talking about surface modeling. If I were to triangulate and contour, and then it says, okay, select entities, depending on whatever switches I have set in my dialog box before I get to that stage, it's going to say select entities. Well, it might say select any inclusion boundaries, and it'll say, and so I then pick until I'm through selecting those, and I hit enter. And then it says, it comes right back and says select entities, but the line above it has now changed, and it says now select any exclusion polylines, or enter for none. So I'd say none, and then it will say still at the command line, select entities, and it says at this stage, the line above says select the points and break lines that you want to use to model the surface. And that's when you go out and grab everything out in the file you want to use. So keep your eye on that, because just because it says select entities doesn't necessarily mean what you think it means. It took me about a week when I was learning the software to realize that it was asking me for different things sometimes. So just be aware of that and keep your eye on those numbers. Also, if you go to, um, say, run a command that computes a point and you're going to turn an angle, you'll see a little help line right above it that tells you what the angle codes are if you don't have them memorized. Okay, so it's again a nice little, if you open it up to about 3 lines, that should give you enough. And you can always scroll that list. You know, you can click in it and just roll the wheel mouse, or um, all kinds of things you can do with the command line itself. Okay. Couple things down here on the status bar that I like to show is my running coordinates over here, and I keep them as specific coordinates. They can be relative, absolute, or geographic, meaning latitude and longitude. Um, your grid snaps and perpendiculars and all that kind of stuff. I usually have on my snapping reference lines, so I'll see the little projected lines. So if I'm going to just draw a couple of little polylines out here, and I'll repeat that command, and I'll go from here to here, for instance. And so now, if I wanted to draw another line at the point where these 2 lines are going to intersect, I might say, let's draw this another command. Say, okay, now I want to go from, say, I'm going to hover, and when that endpoint shows up, see those projections? That's vertical and horizontal, or you see how it extends the actual line itself. So if I got that one, now I'm going to go back and hover here, and I'm going to pull its projection out, and you're going to see when they meet. That's it. I think I've lost track of this one. Let me get that one again now. And now when I come up here and meet, the actual intersect should show up. Now, there it is. So now when I click right there, that's the actual point where these 2 lines are going to intersect. I couldn't really see through that little big yellow circle. So if I actually did, um, you know, fill it here, if let's do a join nearest, and let's pick a gap big enough. So from here to here, you can see right where they intersect is where that point started. And I did that with those projection lines. So I like to keep that out there. It lets me do my point picking a little bit um, more on the fly with certain things like projecting out those directions and things like that. Okay. So that's there. There was snapping. Always have your snapping on, and always have these ones that you use most often selected in your settings, which you right click and choose that, and that'll show you where those are. Now, I usually also show my line weights, and I looked in here, I don't see my line weights showing, so I'm going to click this little menu icon over here, and I'm going to look for, oh, line weight is on, but where is it? Oh, there it is. I see. It's just not turned on. So I'll click it, and it's now turned on. In IntelliCAD, you can't, you don't single click these, you double click them in IntelliCAD. So the only difference there. All right. So that is, again, like I said, the sort of whirlwind. You're going to be setting up your own interface to make sense of the way you work. But that's where you find those particular things. Now, in terms of the settings files, if you look at settings on the settings menu, here's where you set a bunch of different things to configure the software. So we're going to take a look at this with the settings menu, and we've already done these drawing setups and stuff from our startup wizard. So let's look at the Carlson configure system, and this is the overall global configurator. that sets behavior of the whole system. And we're going to go through those really quick and show you what they are. The ones that we're going to ignore these down here at the bottom until we get up here to survey settings. I'm going to click that. And here's where I think the default, you see that set to compact, and you'll see a little menu up here in the top in the survey module that says CG menu. If I had it turned on, and I'll do that and say exit, you're going to see that menu is going to show up right here. It is CG survey. It has a file menu. It has a traverse menu, Kogo, draw, management, all of those different things that you can run from the old CNG software. It's the entire CNG system built in as part of it. Okay, so I'm going to come back here. Now, I don't use that, so I don't have any need for it. I'm just going to pull that down and choose none. Now, I've got a couple of things here that are settings for when when I'm running coordinate geometry commands like traverse, side shot, etc. I can have it show me the occupy and backside points on the status bar, and it'll show up down here on the far right, tell you what your points are, although you don't even really need to see that. You can always just do a quick inverse, and that sets them. You can tell it to automatically turn on a raw file. So anytime you issue a Kogo command, it's going to open a raw file and start recording those actions. And you can either open a new one, open an existing one, and append an existing one. And an automatic line on will draw lines between all of the traverse computed points, but not to your side shots. And it just automatically creates those as drawn lines in the drawing if you have those on. Automatic point object snapping being on or off, that's a good setting to have. We'll show that in a little bit here. And then one thing you do want to, well, I guess that's it. I would keep that automatic point object snap on, and you set your angle mode up here at the top, choose whether you need the CNG system, and that's basically what you need there. So surface settings, there's a couple of things to make sure you have on. It's these bottom three: track 10 history, include detailed source, and track the surface data changes. That's for reconstruction if you should happen to do a bunch of direct surface file edits, like adding break lines, adding points, changing the elevations, removing triangles, that sort of thing. I don't generally edit my surfaces that way. If I see something that caused a surface to form incorrectly at a particular point, I will generally look at that and consider the data that was used to create those and decide, let's say if I need to add a break line, then I'll not do it in my surface edit. I'll go back out into the drawing and create the break line so it's there permanently, and then rebuild the surface. But should I happen to add break lines based on a direct edit, if I don't have that 10 history on, if something should happen, I need to rebuild or redisplay the surface, I've lost that edit and I have to go back and redo those edits. So if you have that on, then in the surface manager command, it will be aware of those changes and let you go and include those. Let's say you're merging different surfaces and things like that. It keeps track of all that. So those are the ones that are important to have on, are these bottom three, okay? The project data folders button, that's the one. And again, it's a separate command under the settings menu. This is where you can do that little trick I was telling you about. And if you don't use this, but I'm going to find out what a file is, there's your, particular file type. You can sort by this, scroll down here and find the extension. Here's a PFS file, for instance. I see that that is a draw profile settings file. So it's a profile settings file. So that's what that file is and what information it holds. That's basically what this tells you. And this is a means here where you would normally set things like what layer, or what folder rather, that it's going to go to back when you did this, where you created this particular folder structure, and again, it's arbitrary, whatever you want to use, then you can assign certain data types to those locations as default locations. All right. So that's what I generally use that for, is I usually keep mine at its default to follow the drawing. But if I was working on a project basis, it would go into those folders. And if I need to see what a file is, I'll just temporarily come here, hit that data subtype, find the file, say, aha, make a mental note of it, come back out and cancel that. So it leaves it sitting on my drawing folder that I had before. Okay. The startup settings, again, basically what template name to use as a starting template. And I normally had mine set for that national or Carlson National CAD standards for civil. Here's my project folder default. It's going to start here as a place, and then all the projects are going to get built under that folder. Particular profile is named on installation of the software. I wouldn't change that, but you can if you want to use a separate one. And then a couple of switches in which AutoCAD product to run the different ones that you've got available. Skip the splash screen if you want. And no menu resetting means that Carlson stays as a partial menu. Otherwise, if you do a menu load and you load up one of the other ones, you don't really have a way back to the Carlson ones until you go back and reload a workspace or something of that nature. Okay, then the drawing setup button. This is what you saw in the wizard when it came up, and it offered that 1 inch equals 20 feet. There's my vertical scale. So I've got a few more um, settings out here that I want to use. And I can set a particular point attribute layout. There's a little picture of it. You can see the different layouts you've got. There's point number over the point at the top, the elevation off to the right, and the description under the point. So it sort of centers around the point. I like this particular one here, number 2, as my default. I can make sure I'm on number 2, where all of the attributes of the points are lined up left justified to the right of the point. And you can see there's 10 different ones. Let's see, number 3, for instance, shows the elevation kicked up at a 45-degree angle. So a lot of you've seen spot shots on uh, topographic maps that might display elevations like that. So that's, just different ways of when you draw points, how it's going to create. Whether you're going to use descriptions, elevations, place the point on the real Z axis, label your zeros or not. So all kinds of different things. The symbol name for the points, you don't see a picture of it here, but you can say set, and you can see all the different symbols that you can scroll through and pick. You've got different categories. You can pull down from points. You got points with wipeouts behind them, so it hides anything underneath them. You got trees. You've got inlets and manholes. You've got all these different things. Keith, there's your CNG symbols. If you're used to those would be the ones that you would typically see as part of your CNG software. Okay. So don't forget that this little category is up here at the top when you're looking for a particular point. You can do that. Go out to Carlson community, find other points if you want. That's an internet connection to go out and do that. There's your symbol size, your text size. These are what you want in plotted inches, and it takes care of computing the actual ground distance and feeding that to AutoCAD behind the scenes. And my drawing setup, what to use when I start up the system. Right now, I said use the configuration, which is this, set my scale to 20, all of that. If I said use the drawing template, all of these things will be read from that drawing template file and supplied for you on startup. So even though I'm using a template to get started with other things like layer assignments, all of these settings are going to be read from this as opposed to from the template. You have your choice there. Vertical angle mode, here's our coordinate system. Right now it's set to grid as a predefined, and it's set right now. You see what I'm using is that West Virginia North, and I say okay. And that controls. what happens when I do a drawing setup. Now, finally, we're going to go to our Carlson settings, and I'm going to leave this up on the screen and let you match these, and we'll talk about them real briefly after you get a chance. I'm going to uncheck this use software rendering. You should not use that if you're on a Windows machine with a good graphics card. I don't have access to the graphics hardware through this interface or through my emulator for Windows. That's why I have to have mine on. So I'll uncheck mine. I'll let you match those. And what you see down below here for this annotated for drawing scale, I've got just little prefixes and suffixes. You don't have to put anything there, but I've got a prefix there that says inch mark space equal sign space as a prefix. And then as a suffix, I've got just a foot mark. So that's a double quote space equal space single quote by itself. And that just controls what the actual, if you look down here on my status bar, you see it's now sitting at 1 inch equals 30 feet, and you see those prefixes and suffixes. Otherwise, it would say 1:30, which is just fine. Doesn't matter. It's just a preference there. So I'll leave these here. Set them up to match if you'd like. I'm actually not going to do that quite so small there. I'll make it 0.2, and that'll be 0.5. There we go. So I'll give you a minute or two on that. So I'm not. See anything from there yet? Okay. I'm just talking to myself. Pardon me. I didn't mean to to be. I'm still on the. Uh, I'm not muted, but I'm just talking to myself. I'm looking at a quick email here. So, all right. So, if you should have a chance to get things set from now, here's what these mean very briefly. Use the startup wizard. This is the only place in the software where you can turn that back on if you have at some point said do not use or you said skip startup wizard next time. If you turn it off there, this is where you can turn it back on if you want to use it. Okay, saving your drawing INI files. The INI files will hold a little running list of other file dependencies that you've used as you've worked on this file. So that can be something and it's just a text file. And you can go out and edit that file, read it, and see. Let's say you send this file to somebody else and they say, well, it's asking me for a coordinate file. I don't have the coordinate file. Well, you can go back and read this INI file and you can see the name of the coordinate file that was used when you were doing the work, and then you can send the rest of those support files along the way. Ignore zero elevations means when you're building surfaces or doing anything that requires 3D information, if you say ignore zero elevations, then that allows you to, even if you select something to be part of a surface, if it's sitting at zero elevation, it will not be part of the surface. Okay, otherwise with that off, it will be. And that again is a switch you can change on the fly during the other commands, but by default, it's going to be set to ignore. The other three for the DView twist and the dimension scale and the A units to drawing scale are just things that help match that up with the standard settings from the AutoCAD variables that it's talking about there. And the enable file selection graphic preview. That was that little preview box I told you about in the Carlson file open. If you don't have that checked, you won't see those little preview boxes that give you that extra little bit of information. I like to see it. There it is. You can set the menu bar on startup if you want, and that's using the menus up here, which you don't have to use. You can do it all from the ribbons. And then the AutoCAD menus, it means if you switch from the Carlson stuff to run AutoCAD by itself, which menu do you want to use? And just a standard AutoCAD menu or the Map Classic or Map 3D or whatever you may have installed in your system. Okay. Selecting the active scales, that has to do with or annotative scales, that has to do with the ones that are predefined, which you see there with the colons in them. And then I've got these two that are actually duplicated because I also have a 1:20 and 1:30, but I had mine set from the time this was a 20 scale drawing. I changed it to a 30 scale, so that it's now built those on the fly. And you can choose to whether they show up or not. If you don't ever want to see 1:1, for instance, you could just suppose, oh, I got to uncheck up here at the top. And now I can say, don't display that one and don't display this one. So you won't see that list when you go to pick a particular annotation scaling from the toolbar down here, or the status bar down here at the bottom. All right. The other things up in the top are pretty self-explanatory as to what they do, as to your reporting order, etc. Your digitizer settings. Unless you're using a digitizer tablet, just go ahead and choose use mouse. Otherwise, it's going to try to go out there and turn on a tablet if you get into a command that relies on digitization. Not really any particular I've run into. Nobody that I know of uses a digitizing tablet anymore other than Bruce Carlson, because he has one of those roll-up digitizing tablets. He loves to go out on a job site, pull out his digitizer tablet and lay it out on the hood of his truck, and then hook everything up to it, and then he can digitize paper drawings right there in the field. So anyway, that support's there if you want it. Finally, on the right, the Carlson file format. Coordinate file format is set by default to Carlson alphanumeric. That means the point numbers can have letters in them if you want. You have that database file as a separate one. It's also still Carlson, just in a different form. But it tracks GIS information as part of itself. Otherwise, if you're tracking GIS information using Carlson alphanumeric, it links it to other files of the same name with a .gis extension on it. So it just keeps two files, pairs them together. The CRDB file holds everything in one file. Then you got the two C and G alternatives as well. The object linking is whether or not, when you put points in the drawing from a coordinate file, and then if you move the point in the drawing, just graphically pick it up and select a grip and move it somewhere else. If you link it to the coordinate file, it's going to automatically update, although now it prompts you, but it's going to update that position information back in the CRD file. You don't have to constantly keep updating the CRD with changes, which you can do separately. Also, if you make changes in the CRD file, it will reposition the point out on the screen, so it links those together. Linking line work with points means any of the vertices of any line work that you draw, or centers of circles and arcs and such like that, if they were defined by using a point from a coordinate file, then if those points should move, the line is going to move with it. Now, however, if you have done that and then you go out and grip edit that polyline by just selecting it, get the grips on, clicking the grip and move it somewhere else, that does not pull the point with it. That just changes that line location. And it stays there until something affects the point that it used to be created from. So if you were to edit the coordinate file and then save it back, and then it will automatically pull those vertices back to those point locations. And sometimes you don't intend that to happen, but that will be what will happen if they are linked. And you can link line work with center line. So if you've created a center line alignment based on a polyline location or a polyline in the drawing, then they're linked in both directions. If you edit the centerline file where you're actually working with the numbers that define the centerline tangents and circles and spirals and such, then when you save that file, it goes back to the drawing and sees any line work that was used to create that centerline file. It will change it. It will automatically redraw it based on the numbers that you've changed in the centerline file. Likewise, if you simply grip edit that polyline out in the drawing file, it will go into the centerline file and update it based on those new positions. Okay. Group point entities means when you have a point and you select it, they're all selected as a group instead of individual entities, like individual attributes and symbols separate from the point itself. And then maintain a coordinate history file is pretty good to have because it lets you step through any changes in a coordinate files, like somebody may have edited points and moved them, so it tracks all of that stuff for you, and you can undo those changes to the point locations and those point entities down through a certain level. You say, all right, roll it back to this level so I get rid of that particular change that I made. And you do all that without having to go through the AutoCAD undo command structure. Because let's say you made some point edits and then you edited some more, you drew more features, you uh, did some other things in the drawing. But if you then decide, I don't want to do those point edits, if you just use the undo commands, you're going to undo all of that other work you've done. If you go back to the coordinate history file and undo that, it only works on the points and that point history, not the intervening other commands that you may have run. Okay, so that's what that's for. And then finally, on that object linking topic, keep in mind whatever this setting is on whoever's computer is working on the file at the time these entity types were created, like points and line works and center lines and such, whatever that setting was set to or not set will govern the behavior of that feature. Even if I have mine on and Joe Schmo across the hall had his off, he drew a bunch of center lines for me, I get the file, I may expect it to automatically update, but he had his off and I may not, so I may go make a subtle change to like a curve radius value or something, and I'll exit and expect that center line that was drawn in the file to be updated. But if he created that center line from that polyline with his link off, it behaves that way for me as well, even though my link is on. So it only has effect at the time of creating those particular entities, and then that lives with those things from that point forward, regardless of whoever else may edit the file and whatever their settings may be. Okay, so keep that part in mind. Now, the remove arcs methods here is when you have a polyline that has an arc portion in it. Let's say you're running down the edge of pavement and you turn into a driveway and there's an arc. So you get to the start of that arc and you might call that EP for edge of pavement, and then you'll do another little description that says PC, meaning that's the start of a curve. And then you get a point on the curve, you just again call it EP, and you get to the end of that arc and you'll say PT. And so it computes and draws a circular arc, a portion of a circle as an arc around that corner, and then you go on your merry way, do other EP points, etc., etc. Now, that stays an arc as long as it stays two-dimensional. As soon as I want to convert that arc into its three-dimensional line work representation, in other words, it reads the elevation of the points, maybe that I've actually surveyed on the ground, and I want to create that line work up in 3D where it belongs as part of being a break line, for instance, then it can't make a true 3D arc, because what you've done, if you've held a corner at the PC and then you've got a different elevation at the PC or the PT, if you're holding the PC and you pick up the PT and raise it up in the air, it's now, even though it still looks like an arc in direct plan view, the entity itself would not be an arc because I have to look at it perpendicular to the entity, look at it perpendicular to the plane that it lies in at this point. And if I've now picked up the line and pulled it straight up vertically, if I shift my perspective and look at that thing perpendicular to its plane, it's now no longer an arc. It's stretched out. It's elongated along its previous chord axis. So it cannot compute what would be a true 3D arc. So it has to remove that arc and replace it with a series of chords. And they're all just directly connected end to end. And those are your two methods now. You can use compute however many chords you need so that the maximum offset of any of those chords away from the original arc in plan view is going to be less than, in my case, 2/100ths of a foot. If that number is too large, you will get too few chords to represent that curve. Now, maybe all you need to compute your surfaces and such like that, but then if you were doing this for, say, setting something up for staking out or putting it on a bulldozer with GPS control on it, you're not going to get that smooth looking arc around the curve. You're going to get those, whatever those segmented pieces are, however far they're away from the original location. And so it's not going to, create that as a very smooth object out in the field. So you want that number to be small enough so that it's within livable range of being away from that circle, the original 2D circle. Now, you may be tempted to set that number to something like 0.00001, so it's really close, but what that does is it makes all of these additional little segments, and it makes more than it needs because every one of those little segment endpoints is going to be part of a triangle in the surface that gets generated. So you have all of these unnecessarily complex areas through arcs that have all these hundreds and sometimes thousands of triangles just around that arc. So to keep that and keep your surfaces a little smaller and more efficient, we want that number to be bigger than something microscopic. So I say in my setup here, I'm saying I'm willing to live with as much as 2/100ths of a difference off the original arc for the chords that go around it. All the imports of my chords are going to be on the arc, but the separation away from the chord distance is that amount. Likewise, you could choose to use the chord length method instead of the offset method, in which case you would say, make me a series of connected chords such that those chords are 0.5 feet in length. Okay, or that they don't exceed 0.5 feet in length. It could make them slightly smaller because it goes from the start of the arc to the end of the arc with an even number. So whatever that number is, it will compute those around the horn. So you can see if you're doing that same scenario around say a driveway curb return, if you have that number sitting at like 2, then it's going to make a 2-foot chord and fit in those circles. So you're not going to get it very well defined as to its original shape, which is what you want with that command. Okay. So that is it in terms of those particular settings and what you need to know and how it works. I'm going to turn my software rendering back on and we'll say, okay, so just keep those things in mind about the linking if you had them turned on or not. And then we are done. We'll say exit. Now you're going to get another box because I changed my drawing setup change, and it's asking me if you've changed the drawing setup change that you want to be in play. Do you want to be that in play for this current file as well as future files, or only for future files? So if you already got something else you don't want to switch to that, then just say future files only. And that's the extent of the settings. We'd still have this one that we'll see later called this point object snapping that we set up in the survey configuration button to turn that on automatically. And that's going to be a separate and different snap function that works with Carlson points. Now, we will run through that points exercise. First of all, let me sort of poll the class. How many of you are really familiar with points and you don't really need to spend any time with it? Or is anybody, yeah, it's sort of a new concept. I'd like to see it. And because we can do this fairly quickly to run through it. It doesn't take a lot of time. But I don't want to necessarily, beat a dead horse. If everybody knows points and uses points and point groups and things like that, then we'll skip ahead and not do that. So let me know. Either just unmute and tell me, yeah, you'd like to see it, or no, let's skip it, or send a chat, whatever. I tend to not use points at all, use C and G points. Okay, well, yeah, but they behave the same way. So if you're familiar with using C and G points, you've sort of got that system under your belt. So that's fine. Anybody? That was from Keith. Who else? Everybody's that a yes or a no? I don't know. You want to run over the points, you'd like to see it. Okay, as long as there's one of us, then I'll run through that. And we'll pick that up. We'll get things set up here, and then we'll get things. We'll run through the exercises as soon as we come back from lunch. Which I'm going to break for lunch at 12:30 at the half hour point, and it's about a half hour later than the actual midday break, but that'll be fine. So let's get started with that. And if you look in our book on our point exercises, let me get one of these things out. Whereas there, I can now back it up. It's on page 13 of your manual, your point exercises, and you're going to, whatever drawing you're in, we're going to set this coordinate file to this one called exercise one coordinates.crd. Okay. And you do that from the points menu, set the coordinate file. So let's do that now. So let's go to the points menu and let's choose the set coordinate file command, which is the sixth one down the menu. So we choose that, and it's going to ask you to pick a file. Again, you've got new and existing tabs. Here's your dialog box. And the one we want, these are the files in my folder. Skip past those dot underscore files, and I'm going to look at my exercise one coordinates. That's the file I want. It tells me in my preview 12 points, or 22 points rather, and I'll choose open. Now, I've got those points open in a coordinate file. There's nothing in my drawing, nothing has happened here yet, but if I go to my points menu and choose list points, third command down, I'll list all points. I'm not going to use any of these particular things. I will report the range. You can put the point number or job header that you might want to see that kind of stuff. And I'll say, okay. And now here's my points. And I see there's my project, Carlson survey class, my location, Pittsburgh, PA, my job number 123-ABC. We did that in our drawing wizard setup where we set those values. Then it tells you the file name, then it lists your points, and at the bottom, it tells us that we have a mins and max for the X, for the Y, for the Z, and the total number of points, okay? Then these particular columns here, again, it gives you point number, the northing, which is your Y coordinate, easting is X, and elevation is Z, and descriptions, if you had descriptions, these don't have descriptions on them, so you don't see them. So that shows us what points are there. Now, as we get our file ready to come back to after lunch, let's bring these points into the drawing. And how do you do that? There's nothing in my drawing yet. So we're going to go to the points menu, and we're going to choose this combination command called draw locate points. Okay, we do that. It now tells you at the top what coordinate file you're using. You can also set it there to a different one if you want. Shows you what symbol you're using. You could hit the set button and choose a particular point symbol. If you wanted to change it, we'll just keep those as that. We've got these particular things I want to be using. I want to use point numbers. I'm automatically point numbers. So if I'm creating points, it's going to go to this next available. There it says 23 is my next available. I can call that 101 if I want or anything else. I can limit my points to draw based on a description wildcard. Right now it's set to everything. That's an asterisk. How to handle any duplicates. You can either allow them, so it puts 1 point right over top of its own self. You can erase and redraw the point, or you can draw only the new points, leaving the old points alone and unerased. So leave them there. Again, your symbol size, scalar, your text size, scalar, based on your original, but you can change it here on the fly. And then finally, the layer that they're going to go on. Now, you could say, make a layer and put these on layers based on the description. And then you could put a little prefix on that if you wanted to sort of give you a way in your layer listing to look at everything that starts with a PT underscore or whatever you put in there is going to be the layer those points live on. Or uncheck that. And if you put a layer name down here, and again, you can type it, and if it doesn't exist, it makes it. If it does exist, it uses it, or you can select from a list here of things that already exist, that sort of thing. And then the buttons at the bottom now control what we're going to do. Now remember, it's a combination command. It draws new points. It also or draws points from the file, or it can locate points. In other words, create points based on us picking a point or typing a coordinate value. So we're going to be drawing them. So we're not going to use the screen pick or the enter and assign. So we can either draw a range of points or draw all. So let's draw all. And when it does, it's going to draw out here in the drawing. You're going to see that. Now yours will probably zoom to show you those points. I have a setting on mine that doesn't do that. And that's under my points, point defaults. And down here's where I've again set my attribute mode as to attribute layout ID is 2. That's just right here. So mine are going to be left justified. It's going to use that point. So it's very much a lot of the same settings here. But I have unchecked this little box right here that says auto zoom to center of the screen for new points. Now, that's helpful to have on if you want it to jump to that location. Mine was off, I think this last time, just to demonstrate that it didn't work. And then if I say, okay, that's my defaults, and if I redraw the points, it would now zoom, but they actually exist out here in my drawing. I need to see them, so I'm going to zoom extents, which you can do view, zoom, and you would say all, or actually zoom extents right here. Or you can type zoom enter or Z enter, that's a shortcut, and then E enter for extents, or an even shorter shortcut is use the wheel on your mouse and double click the wheel. When you do that, it does a zoom extents, and there's your points. And there's going to be the ones you can now zoom in with your wheel mouse, and you're going to set that. These are going to be our set of points that we're going to be working with when we come back. Okay. So at this stage, let's save the file. So I'm going to just come up to my icons and hit the save button. It's now saved. So when we come back after lunch, we can pick right back up where we left off. Okay. So any questions at this point so far? Everybody good with all the boring crap? Okay. So I'm going to go ahead and stop our share. And I'll pause our recording. Tell me that what happened in your other day in your last week class, but we went a lot longer than that. So we're we're just at this point talking about points in our drawing and coordinate files. Thank you, Scott, for pointing that out. I appreciate it.
Yeah.
All right. So another way to move those things around now, we're talking about under our points menu, this block of commands in this bottom portion called that all work with attributes. So if I move point attributes, it wants me to select the attribute to move. So maybe I want to select that elevation, and notice when I move it around, maybe I want to put it over here on this side here. And it lets you set a rotation value. I just hit enter to keep it the same. I can move the point number. Let's put it, say, straight over top. And then we just hit enter, set our rotation. Okay. Same thing here. I'm going to move that to right there. Choose the text, set its rotation. Now let's move it one more time and put it right up here next to the point. And so that would be sort of like a spot elevation. And we would typically at that point say freeze. So I'm going to go to my view menu and choose freeze layer by pick. And I'm just going to pick the point number. So all the point numbers went away because that's on this layer here called point, this layer called PNTNO. That's my point number. So that got frozen. You can see under the column right here under freeze. You see how that's looks like a snowflake instead of a sun. So that tells me it's a frozen layer and I don't see them. All right, so I'm going to reset using my toolbar now. I'm going to thaw the ones that I froze. All right, so there they are. If I double click this point, notice right in here, I've got two descriptions. I have a drawing description and I have a coordinate file description. So maybe I have a coordinate file description that says 12D oak. I want to do that and said okay and just come back now. If I don't see that here now because I drew it when it didn't have one. So if I go back to my points location, draw locate points, I'm going to draw a range of points in just point 19. So I'm going to say draw a range. It says point numbers to draw. I'm just going to say 19, hit enter, then hit enter to finish. So now I've got this description that says 12D oak. And by the way, this font that you see for these points are that's created for you the first time you draw a point, and it's a style called PTXT. And if you want to change that, and I will because I think that's the god awfulest looking set of text ever, but it came about from the days when we were used to working with pen plotters and you had to draw these characters faster than we normally would. So I'm going to go to my draw menu because this has to do with drawing text. I'm going to go to pull up the text menu down and choose set style, or I can simply type the command style and it brings this up. Now you see I've got all of these other styles that were I'm sorry, these are fonts. The style itself is font name. So over here, so I've got one called PTXT. I've got one called standard that's built with that particular font, Arial. So if I look at this PTXT, and I don't want to change the name of that as the style name, I want to change the font it's built with. So I'll sit on that and I'll look under my font name, and I'm going to go up here. I'm going to make that a font called Calibri Light. That's what it would look like. I'll say apply, close, and now you see it has updated. Instead of that little thin, skinny type thing, I now have a nicer looking font. Okay, so now when I look at this, if I were making a map out of this, what else might I do instead? Or if that's an oak tree, a 12-inch diameter oak tree, if I double click that point again, I'm going to edit that point. I've got several features about that. You see these tabs at the top, one of which is this GIS tab. If it had GIS attributes on it, I would see them listed here if I'm collecting GIS data. And then in this particular case, they tell you that this requires that CRDB format to be able to show you those in this editor. Otherwise, it's in a separate file, and it can't show it to you from this editor. All right, so let's look at the symbol. So if I click here on the symbol, and I'm going to hit that button there that shows me the symbol name, or pull down or hit the set button, either way. I'm going to go to my categories. I'm going to switch from points down to trees. And let's make that, oh, something like that, and say OK. All right, so now I have a red looking tree with a description of 12 DOAK. So you can do, maybe this whole point. If I select this point, maybe I'm going to put that on a new layer. And let's see if I've got a layer here. I don't have one. No, let's make a layer called trees. So if I create a new layer, call it trees, I'll make its color green so that when things draw by color, they will show up accordingly. Now, all I've done is made a new layer. If I want this to be on that layer, then I simply select it. And in my layer list over here, my properties, you see it's sitting right now on PNTS. Okay, so I'll pull that down. And I'm going to put this on layer trees, which was defined as green. And there it is. All right. Next thing, well, what if I wanted, instead of saying 12 DOAK, I wanted to say 12-inch diameter oak tree. So if I double click it again, and let's go back to our general tab, notice we have these two spots. The first thing I had done was to change its description to 12D oak. And then I redrew the point and it put it in my drawing using the same description for the drawing file as it has in the coordinate file. Okay, just standard behavior type differences here. So one of the things I might want this to read is my description in my drawing. I might want it to say 12-inch diameter oak. Or let's go ahead and spell it all the way out, oak tree. Okay. Now, when I do this, I'm going to say, okay, and now there's my drawing, and it has this description for this point, in which case I could also, once I'm done and ready to plot my mapping, I could turn off these individual attributes, and I'd see my symbols and my descriptions for my point. But let's look at this point. If I double click it again, I see there's my two different descriptions, right? If I go back to my points menu and list points, I'm going to see point number 19 that I'm editing only has, is the only one that has a description of 12D oak. Okay, so this is sort of setting the stage for what we're going to look at as our next big jump off point into this afternoon is these the field to finish work, is that based on that description, that 12D oak, I can tell it, and instead of drawing these red plus marks on that layer, I want you to switch to this layer and use a tree symbol. And then I want you to also write out this description. So none of that has to happen in the field as you're collecting the point, or even if you're editing the points later. It only happens when you run field to finish, and it reads the code that tells it all those things. It tells it which symbol to use, what layer to put things on, what description to use, and whether or not to connect it to other points with the same description with line work. And as you can imagine, in the case of trees, we would not want to draw lines between all our trees. But in the case of, say, edge of pavement, we're going to go out and gather up all our edge of pavement shots, and we're going to have it draw that line work as we gather in those points. So when we come back to the office through field to finish, we have a code for EP for edge of pavement that says, yeah, connect it with drawn polylines, 2D or 3D polylines. So field to finish eliminates us having to do all of this kind of manual editing in our file once it's drawn. Okay, so that's why these points, when you look at them in the point editor, in this double click editor, that's why you see these two different descriptions. Now, go back to the points menu and choose edit points, which is a spreadsheet editor for all the points. You see, it's here. It has only the one description. It does not show you the drawing description because, again, it's not even really looking at the drawing. It's looking at the coordinate file. And that is the description in the coordinate file, 12D oak. Whereas in the drawing file, it's already been placed here. It can have a different description. That's why that description shows up in that double click editor, because it knows that point's sitting right there on the screen. The other command I just ran, list or edit points, the spreadsheet view, it has no idea whether I've drawn that point into the drawing or not, and whether it has any kind of different description. Those different descriptions do not go in the coordinate file. They just stay with this thing that was created in the drawing. Okay. So I'm going to turn my layers back on again now, just thaw them all back so you can see the rest of them there. And all I did was to freeze those layers being these right here: point description, elevation, point mark, that's the symbol, and then there's a point number. So the point number is the point number, the point mark is the symbol, the point elevation, and then the point description. All right, now you can freeze and thaw any of those layers independently of the others. So let's see, if I chose this point mark and I froze that layer, oops, not set the color, but freeze it, come back to here. Now, when all layers set on, I thought I froze that point mark. Free, not the elevation, just the mark. Okay, so the mark is not. Oh, I think I know why here. I'll fix this in just a minute. In fact, if I make this, instead of red, let's make it cyan. And say, okay, but these stay red, they're not cyan. And that's because this point mark, when this point gets drawn and created, it goes on this layer. When I did points, draw, locate, down here's the layer at the bottom. Oh, and let me turn my little marker back on again. Sorry. So there we go. So it would go on this layer called PNTS, and so that's now where it lives. But all of those other layers, the point number, point elevation, and point description, they all have their own independent attributes. The ones where the symbols live are on, in this case, PNTS, and that's the same layer that the actual AutoCAD point entity is on as well. So if I freeze that one layer, PNTS, so I'll go over here and find PNTS, that's going to freeze basically everything. So that turns all those things off, except for that one, of course, because why? I put that on a layer called trees instead of PNTS. All right, so you can control your visibility of these things based on several factors. That's one of which you can also actually go through and erase the points you don't want to see in the drawing. They do not necessarily come out of the coordinate file as well. You could say erase them from the drawing, but not the coordinate file. All kinds of ways to take care of that. All right. So when field to finish is going to do something like this, instead of putting this point on that layer PNTS, in which case I can't control the symbol. But in this case over here, I still don't think I can. Let me see if I freeze that. Yeah, it's the entire layer. Um, so the way you can get those symbols on that layer called point mark, just like point no, point elif, and point desc, there's a point mark layer for the symbol. And for it to be on a separate layer, when you draw locate these points, um, and let me see if there's a switch in here. I think so. Mm, So I'm going to cancel that and let's look at the points menu in the very first command, the point defaults. And does this. I'm looking for mask the attributes. I'm looking for the option to put these on different layers. That's his vertical angle separate. Oh, right there it is on the far right. The separate layers, right now I say none. If I want my points, symbols, or both to go on separate layers, I'm going to say both. And in this case, you will see what gets created. So I'm going to go back now, and that's my default. I'm going to draw locate points now. So go back to points, draw locate points. And I'm going to draw a range down here. I'm going to say 1 to 18, and then 20 to 22. So, and then I'll hit enter to finish. So now I've recreated and redrawn those points. So now if I should freeze that layer, I'll just go to my freeze layer by pick and freeze the point symbol. You notice that went away. This one did not because it's on a separate layer. And now I've got things on that layer. I've got this one is the point mark layer. Notice the this little snowflake telling me that it's frozen. So that's what happens when you separate the attributes and the points. They can be placed on their different layer. Now that particular points, I also told it to put these things on a layer called PNTS. So if I select that item, I see it's still on layer PNTS. If you freeze layer PNTS, everything goes away because the point is inserted on that layer. It's that sort of parent-child relationship. These other layers, like the PNTNO for point number, or the point elevation, point description, those are actually where the attributes of this graphic block, or the point number, elevation, and description, they are created to be on those particular layers. And because I said separate layers both, then that took the symbol, which in our case, let me turn that layer back on as you can see it. So that took our symbols, and the separation flag was set on our point defaults. And so therefore it put the symbol part onto a different layer than the main layer that we set under points, draw locate right here, called PNTS. So the overall total group lives on PNTS. If I freeze that point, they all go away that were on that layer. If I want to freeze just the point symbols, then I need to separate those. Otherwise, when I click the symbols, the entire point would disappear because it would be on that same parent layer, if that makes sense for everybody. I wouldn't worry too much about it, but that's just sort of how that stuff is related. It's related to the way blocks are displayed. So if I turn off this layer again, I'm going to pick it and pick the symbol. So it's now there, but now what do I have? If I select that point, can you see that little dot right there to the left, right there? See that little dot is down there. That's an actual point. It's an AutoCAD point. So if I select this, you can barely see that little dot light up. And that's because of what our point mode, our point display is set to. And in general, the Carlson points usually set that to just show a dot so that then when they put a symbol over top of it, it wants to draw a particular symbol, but the dot will always be visible so you can see it and locate it and find it. And it is a standard AutoCAD entity. So to be able to see those a little better here, let's go to the settings menu and come down to our AutoCAD settings. And we go to the right and we want to set our point style. So this is going to bring up the way AutoCAD draws point entities. And right now you see it's set to the one that shows them as a period, just a little dot. The one next to that would be don't show it. In other words, just have nothing there. But I want to use, let's say I wanted to use an X with or let's use a circle with a X through it. So if we use that as our point size and say, okay, there it is. But that's unlike the Carlson symbol, which I still have frozen. Let me thaw them again. See, there they are, those little plus marks. So unlike that, this thing, though, is not, it's not a drawn block like the other one. It's actually the point itself. And so usually that is created or control governed by rather this where's my recent command that I was doing? Let's see, I froze. Let me thaw that back here now. Oh, now I got them back because the plus mark is there now, as well as uh, crap. Let me see. What did I do? What did I do? Okay, so they're now all thawed and on. So everything's there, including the AutoCAD point, which now looks like this X with the circle around it. But you see the plus mark, that's the actual um, Carlson symbol. And let's go back to my settings menu, AutoCAD settings, and set my point style. This time, instead of being that one, which is a little bit confusing, let's make it just, let's say a circle. Okay, so the circle displays, the pluses display, and if I then freeze off our plus, which was on that point mark, you're left with just these circles. Okay, but again, that layer exists and it holds the definition from that block insert. Okay, so anyway, a little bit too much depth of trying to get into, but I'm just sort of setting the stage for field to finish because this is where this is going to take great effect. Is it's going to read those descriptions and use those descriptions to help us draw the drawing, help us generate things in the drawing. Okay. All right. So now, again, what good are these point numbers? How are they going to work? Let me go back to my settings and AutoCAD settings and point style. I'm going to reset it to that upper left, which is a dot only. And I'm going to thaw all my layers, which will thaw those point locations back, the point symbols. Okay, so now got a bunch of point symbols. I got a bunch of points, and they have a symbol, an AutoCAD point, and a block of attributes. So, um, so what good are they? How are they going to help us? And here's how they help us. If we draw a polyline, if I choose the standard P-line command, the AutoCAD polyline command, let me get the right one. So it says polyline, specify a start point. Well, I may say, click out here in space somewhere, but if I want to start with point number 1, I'm going to type 1, hit enter, and it says, where's 1? Well, you see, it found 1. I don't know why that's a particular one. I think that's the I think that might be let me take a look at this endpoint. No, I thought it was going to be sitting at 1 as part of its coordinates or something, but it's not there. But in any case, I would have to then, I would have to point to every one. If I wanted to draw that 14 through 18. So I'm going to go to my Carlson draw command now instead. Well, let me say, let's repeat this with the AutoCAD. Specify the first point. So now if I hover the mouse over any part of that point, that's 14. Now look here as I hover over 15. I get a little marker, and then I get a pop-up that tells me it's point number 15, northern eastern elevation, and what coordinate file that it was used from to link into this drawing. So now I can click that point. So that's 14, 15. Now the reason that's snapping, even though I'm not pointing to it, is because of that point object snapping. So there's 16, there's 17, there's 18. Whoops. Let me undo 18. I didn't take. Let's try this a second ago. Let's do just one. All right, so all right, so back to that. So I'm gonna hover, I get the snap. There it is. I'm gonna wait for it to show up. I can't see my cursor very well. I'm sure you guys might. Oh, here it is. So left click, right click. All right, let's try that. So I can see it. All right. So specify the start point. Well, that start point, I'm going to go up here, hover, and wait for the grip to show or the snap to show. There's 15. There's 16. But now what happens if I hover over near this symbol? Well, if I did that, notice that didn't go to point number 17, did it? It went to the endpoint of the symbol itself. Because I have down here in my settings for my object snap settings, I say I want to use endpoint snap automatically. So it found the endpoint of that symbol before it found the actual point itself. So a much easier and more coordinated way of doing all that instead of click, click, click is when you run a Carlson version of that command under the draw menu, 2D polyline, and we can do some options here, like it can read the elevation of something you might pick as the first point, and then set everything accordingly from there, or you have it unchecked and it would be down at 0 or whatever elevation you type here. And again, it's going to be 2D. So I'm going to set the elevation by the first point. I'm going to say, okay. And now it says pick a point down on the command line. It says pick a point or point number. There's your savings. So 14-18, hit enter again. There's your line between all of those points. And you can see now, obviously, for 5 points, it's not that big a savings. For 500 points, you're going to save a lot of time. Now, remember the option when we drew that 2D polyline, it said set the elevation by the first point that you pick. And remember, I snapped to that 14, or I typed 14. So that line should be at an elevation of 154.77, its entire length, because it set the elevation from the first. It is a 2D polyline, so it does not change elevations. I select it. I look over my properties, and I see the elevation is 0. Why did it do that? No, did I have the switch on? Well, let's see. This should be a 2D poly. It says set elevation by the first point pegged. Okay. To the insert of. No. Let's see here. Oh. Yeah, there's your first point. Okay, now, so if I set that as here, and then 15 through 18 to hit enter. Right. Yeah, there you go. You see over here in the elevation field, it read the elevation of that point that I snapped to and used that for the elevation of this entire line. In fact, if I look at that in 3D, I'm just going to do a little spin up here in the editor. You can see how it starts at that elevation, but stays at that elevation all the way around itself. It's just sort of picked up and elevated okay. Otherwise, no, that's because it's two-dimensional. It cannot have changing elevation. It could be it's constant elevation, but it can be non-zero. Now, if we delete that and then run instead this 3D, that Carlson draw 3D polyline, and you can put it on all the layers, different sizes, things like that. And I'll say okay, and I'm going to just pick. I'm just going to type 14 through 18. Enter twice, and now you can see they each have their own point elevation, including these smallish contours. So just a couple of nuances about those lines. 3Ds will read through the elevations of all the points. 2Ds stay constant, but based on a first point picked. If that was your intent, I'm going to go back to my plan view now by clicking up here in the top and then rotating that back. All right. Oh, depending on the switch, if I'm running a 2D polyline again, 2D, I don't, if I uncheck that, it's going to be whatever this number is right here. So I may want these all on, say, a 200, and I'll go 14 through 18. Look at that in 3 dimensions, and you see it's way up here. It has an elevation in my properties of 200. If I hover over the grips, I see that down on my status bar down here. It's reading, some X, negative 598 in the X, 886 in the Y, and 200 in the Z. So that's how that particular thing works. I'm going to uncheck that and set that back to 0 just because that keeps everything on the 0 plane unless I purposely elevate it. All right. So again, point numbers. Let me go back to my top view. I got something down here. Oh, still have something down here. Yeah, some straight points. All right. Let's see. We were talking about if I draw these 2D polys, draw them by Carlson commands with point numbers, as opposed to the other commands like P line, although you're certainly free to do that. But that's how that works, and how this point object snapping works is by snapping to the actual center of the point when you hover over any part of the point, which would include those descriptions and point numbers. And so that's a way you may not know the point numbers, but you know you want to go to these exact locations. In here, you could just, hover, click, hover, and let the marker show up before you hit click. Okay. Now, that is sort of a little basis of how you can get that done quickly. We've got here, if you look at the we got 22 points, and we got the description is separate. So if we draw a line, draw a polyline, let's say we want to connect, I'm going to select that one and get rid of it. So if we want to select everything or draw a line that goes from one point to the next sequentially, we're going to go to draw 2D, or let's do a 3D polyline. So we'll say 3D. I'm unchecking this little prompt box because I don't want to have to confirm it when it gets to the point and says, hey, it's this elevation, you want to use it. And so I'm going to draw this accordingly through these points. I'm going to say, okay, and it says pick a point or point number. I can just say 1 to 1,000 if I want. Now it ends at 22, so it'll stop at that point. I hit enter to finish, and now there's my point. And I can see as I rotate that up into three-dimensional space, I can see it's there, and all of the corners are sitting at all of those point number locations. Okay. So that would be used to help model a surface if that made sense of being a break line for me. It's not really all that much of sense being made, but you get the idea. Now, one last little quick thing about points is using point groups. So we're going to do this. I'm going to select everything in my drawing and erase it all. So my points are out of my drawing. I do still have points in the coordinate file. That's fine. That's where they're supposed to be. But I'm going to switch coordinate files at this stage. And I'm going to say, go to the points menu and say, set coordinate file. And this time I want to choose this file called exercise 2 point groups. So let me open that file. I now have a bunch of points. They're not drawn yet. If I look at points, list points, all I see, I've got a bunch of points. I've got some BDY points for boundary. I've got some that say BLDG, those are buildings. EOPs are edge of pavement. There's more buildings. There's P corner for property corner and more BLDG. Okay, so again, got a bunch of points with descriptions in it this time. And we can, just draw them all into the drawing if we want. But let's look at our point groups and how that can be helpful. So I'll go to my points menu and choose point group manager, the last command in the upper block. And it's going to bring up this dialog, and it's going to let me create point groups. and edit those definitions and things like that. So I'm going to have a couple of different points. I'm going to have uh, a group called corners. I'm going to have a group called pavement and a group called building. All right. Um, so from that list of points, I want to create a point group. I'm going to hit the create button, or I'm going to go to this groups pull down menu and choose create a point group. So I hit create, and I'm going to call these my corners. As you can be more specific, proper, prop corners for property corners. Okay. I have two ways of selecting them. I can either include certain things or say include everything and then go to the exclude and exclude certain things based on these filtering. I'm going to uncheck that include all, and I'm going to come down to the bottom section now, because if you say include all, they all go into the points group that you're naming, but we don't have any criteria. So it just basically would take everything. So I'm going to uncheck include all. Now I've got the means to filter my selection. So I'm going to look here under description. I'm going to check that on saying, use the description to generate and create a point group. Now you remember those ones that we saw, BDY, EOP, all that kind of stuff. And you can set by selection by, if you got something else that's already um, drawn in the drawing, we could just select those and say, hey, here's a group. But for now, we're going to say set from list. And here's our list of files that are available out of this coordinate file. Starts at the top, there's some BDY points. If I just click one, that's going to preload BDY as a description into my group. And I remember there were some others called P core. There it is, P core. And you see now they're both highlighted. And the way I did that was they weren't. I'm going to click BDY. I'm going to come down here and see there's a P core. I'm going to control click it. So now both layers are selected. All right, so I'm going to say okay. And now I've got this point list. I'll say save at this stage. And I've got this point list here in my listing called prop cores. And I see all of the points. This is like a running file list. So I get all of these points. I see that I've got boundary points and I've got P-core points, which stands for prop corner. And they're all stored in this one group, but these are all total property corners. If I had, I don't know, a center line that I needed to send my crews out and stake a center line, even with, let's say, a 50-foot offset, um, I can have all that done and I can create those points along those offsets and then have that list of points added into a new point group, for instance. And then I can export that group or print that group to whoever I want to get it in the hands of my field crews and say, here's the points, and you just set these. Don't come home until you're done, that kind of deal. Okay. So with this group now, I've got this property corners. Let's add another. We're going to create another group. And we'll call this one up here at the top. We'll just say EOP. I'm going to uncheck include all. I will check to choose by description. I'll set from my list. And let's come down here and find, there's EOP. And then, so I've got my EOP. That's going to be on, and I can again set those from the list, or since I know what that is, I'm going to set this up and I'll say save. There now are my two different groups. If I edit this particular group, just double click it. And if I said down here, let's say BDY asterisk, and that means take any points that start with a BDY and end with anything else. It's a wild card. Now you see I get BDY, but I also get this BDY RAD PT, a radius point. It has a different description, even though it's part of that, there's a point on it, but it created a point at the center of any kind of arc features. All right. So I'm going to take that asterisk back out of there so that it gets only the descriptions BDY and PCOR. Now I'm back to where that was. There's my BDYs and my PCORs. And those are now two groups. Let's make two more. I'm going to say create. Let's call this one BLDG. So there's my building group. I'll uncheck the include all, turn on the description, set from here, and let's find the building points. There was one I remember seeing. Right there is BLDG. That would be the same name as what I called the group. So BLDG, save it. It's now here in my list. And next, I'm going to create one more. And this time I'm going to, again, uncheck that. And for description, I would call this one EOP, I think it said. Yep, EOP. So I can just select one as an example. And there it feels. And then it takes all of the points from that description, save it. Now I've got that in my, so I've got, see, a new group. I think that one I need to delete as a group. Now, if I delete that, it's not deleting the points, it's just deleting it from my definition. So I've got building points, edge of pavement points, and property corner points. Did I have any others? I do not think. There's boundary, building, edge of pavement. Yeah, okay, so that's got all possibilities in our group. So now I've got these point groups. So what use are they? So let's go back next to, again, look at your points menu here inside the manager. You can do all these things with individual points. You can do all these things with and about point groups. Okay, so you can run those commands from inside there anytime. All right, so back to our points menu where we say like list points. If I wanted to see all my property corners, well, I could say list all, and this file is small enough that I could look down here and see, okay, there's boundary points. I'll scroll down and I'll find there's some P corners, there's property corner points, and I've got boundary points, which are all of my my point, all the points along the boundary or along the perimeter of this particular piece of property or whatever it is, this development. So that is, again, a small file, no problem. But if I want to list points, and this time, instead of using the all button or try to filter by description, if I use a point group, notice it puts me just right in the point group manager. So let me select it. There's my proposed corners. I'm going to say OK. And then say OK. And now you see there's the boundary and property corners group. So let's do the other one next. If we repeat that, let's choose a different group. Let's use the edge of pavement group. And now we're restricted to just those particular points based on the group membership. Okay. Now, point groups are used throughout the software if you want to use them in places like what you just saw, draw or list points, rather, based on the group. You can draw points. So if I were creating a stakeout plan to send my crews out to stake out this subdivision, I might go to points menu, draw locate points, pick a symbol and all that kind of stuff. But instead of drawing a range down at the bottom or choose draw point group. I'll do that. I'm going to look at my points and where's my, oh, property corners, boundary is a point distribution. So I'm going to just draw all my property corners. Bada bing, bada boom, there they go. They're going to draw. And now I'm going to zoom extents to get them all up there. And that would be this out, all these points connected out here are my outside boundary. I've got inside, I've got a road that comes into it. So it's got a tier of, um, I'm going to say this is when you see that drawing fully on, there's these, that's the edge of a road around a cul-de-sac. And then these are lots that form all the way around that cul-de-sac. Okay. And if you want to see what that file looks like and where these points were created from, let me show you. We can actually, I'm going to go back to draw again, draw locate points and draw group. Let's do the building group. All right, so now all the buildings are in there. But again, so it lets us manage our points by selecting a group as a collection of named points. But again, we're still sort of, kind of getting a bunch of overwhelmingness here where we can't really tell where we are or what point number or, what each of those particular points are going to be. And what ultimate figure this is going to make. Then we would sit down with our handy little field notes or our memory of being out there, and we'd say, okay, well, I shot this point here. There's 120, 121, 122. Here's 119, 20, 21, 22, 23, 24. So I could then spend all my time drawing. Um, let's draw a 2D polyline. And let's just call that from 119 dash 124, hit enter. And now it wants to know the closing leg. I can either type the number again, but really I've got the option at the bottom of the command line that says C to close because it needs to be mathematically a closed figure. If I had just simply said to draw back to point 119 and then quit the command, then that line is not closed in terms of its mathematical definition. But you see, what I would do is sit down and I would know which ones to connect. And then I would, flip the page of my field book or whatever and say, okay, these are the point numbers now for that. But again, we're doing all of this stuff now as automatedly as we can. So instead of having this just draw a bunch of points, we can draw these points using a process called field to finish. But anyway, as I was starting to say about that file, if you want to see what that file is where these points were computed from, let's go to let's just type the word XREF, external reference, and hit enter. Now in your box to choose, I'm going to right click the mouse and I'm going to choose attach drawing. And the drawing I want to attach, now it's looking the last place it was sitting in for this process of attaching a drawing. So I'm going to go over here and actually work. I'm going to get to my project. So I'm going to click in my favorites. I'm bound back to C, Carlson projects. I need to open up my, wait a minute, Carlson projects. Yeah. So I need to open up my, where is it? Oh, there, I'm sitting on it. I couldn't read through the marker. All right, so there's my folder and there's the data sets folder. So now these are all drawings that exist there. So this one's going to be the drawing up at the top called Civil Demo. And it's going to, and I'm going to say, leave these units as 1 as 0s unless, if you, let me see, leave Well, I'm sorry, leave these, yeah, this rotation. We don't want to specify in the screen. Yeah, these are going to be zeros down here. We don't want to specify an insertion point. We want the insertion point to be 0, 0, 0 so that it's going to line up in the same coordinate space. Same thing with scale. We want to make all ones. You can make it an overlay or an attachment, either one. I'll say OK. And now there's the entire drawing. And you can see there's building points. See how they're just sort of right there. There's a boundary point that's part of that P core or prop corner group. All right, you can see, how they would work. You could then, send this out to your crews and say, here, I want you guys to stake every property corner and every building corner, and then you can come home. And so after a couple of hot dogs at the hot dog truck, they get to work. And as they're working along, they're just collecting points and sticking the description in the data collector and going on their merry way until one of them says, guys, we're never going to get this done unless you want to use, set this up for field to finish. And so that's field to finish, which is what we'll look at next, is a system whereby it's going to take our field work and create finished work inside that file in the drawing. Now you can say, well, that's not hard to do. I just export the drawing information from my time in the field or from my laptop I use in the field. And then I can, bring that back into this drawing in the office. But with field to finish, I wanted to read those points and read the descriptions in those points. And based on those descriptions, I wanted to decide what layer to put things on, what symbol to use, whether to draw the labels or not, and et cetera, and whether they're connected. So field to finish then is a way of taking that field gathered information and bringing it into the office. Now it does require a certain amount of, well, it requires a great deal of setup, but it also requires a certain amount of knowledge of what's going on the part of the guys out in the field. Smaller operations, maybe you're a solo practitioner, you've got a robot and you walk around and gather your points. That other person is going to be you. But you need to know, whoever's doing the field work, they need to know that they need to observe these things out in the field and then give the description codes of those points along with what are called control codes, which will help it to generate lines and line work and arcs and things like that. So if I'd said I wanted to start here on this point one, I don't even see, where's it? Point one, point two is, I guess, over here. Yeah, 1 to 2 to 3, or let's say in a case of these edge of pavement roads, I didn't draw those points yet. Let's just draw, locate my point group EOP. So now you can see all the edges of pavement are labeled. That was a polyline, so I selected that particular, well, I'm in a externally referenced line, or file, but you can see all those points lined up around the edge of pavement. So those would be the things that I would do in the office. I'd say, okay, I need to connect 54 to 56 to 72. And what's the next one here is 70. All right, so that's not going to go in any order. So if I said, oh, it looks like 64 to 72, and if I draw a line, let me draw 2D polyline, and I will change the color here so you can see it. This will be a red line. And I wanted to draw that from, what did we say? 60, no, 54 around to 70. There's also, yeah, so 54 to 72. So if I were to type that 54-72, you see what it did, 54 to 72. I must have, oh yeah. So it went from 54, just like I told it, but it went to 55 next, which was out here, another edge of pavement point. So I started here, went to 55, went to the next one, there's an edge of pavement point. So it's on the pavement, but I mean to be getting these lines down here, not this goofy looking line. Some of which work, like these tangent lines here look like they're in good shape. Same thing across the potential property boundaries. I got the same type of thing. So instead of doing it just by point numbers, we're going to also look at drawing these based on not just on coordinate point number order, the order in which they were drawn, but based on um, the codes that are going to define from those descriptions. So in this case, as an example, if I draw I'm just going to pull down polyline and choose by nearest found. And I'm going to say, let's do a 2D polyline, give it a description. We'll change that to shift 8, which is your asterisk. So draw them all, put them on a particular layer name. So it's not really these all points as a description. I want BDY and P core. I can't really do it. Well, let's just do a BDY and we'll say okay. And select from the screen or by number. So if we select by number and I'm looking for those boundary points, I don't know, 1 through 15 or something. So 1-15, I hit enter. Let's see, select points and hit enter. Okay, there it is. So there was my point 1, started right here, went all the way around the horn to point number 15. But you see right here, that's a straight line. There's no curve in my line. I want there to be a curve in the line. So I would need to, and I can't do it here other than I could say, I know that's an arc, so I'm going to hover over that midpoint grip and choose convert to arc, and then let it find the midpoint of that. And then that now has, just with a grip edit, again, let me make this big enough to see. So if I created that line that I just drew and made it red, line weight was 0.4. All right, and I'm displaying my line weight. So that would be a partial. I went from 1 to, whatever, 1 to 2 to 3 of it based on boundary points. Now, it again missed these. I could individually edit those, but it also didn't put from here to anything up here until it gets all the way up to this end. That's the boundary point. So it actually does live. Let's bring that to my drawing. Or there it is. I'm bringing it up to the front. Okay, so it actually went around to 78, 79. Oh, there's a lot of numbers. Let's see our point number. There's 98, 100. There's 8. So it went from 8 to 9, and then 10 is way up here. So it was probably bigger than the gap that I had chosen. But anyway, it's missing things like not knowing those are curves. I would have to arc and convert it to an arc and snap to that or snap to the corner, all of which can be done. But again, if we're using those groups, and the field to finish concept is when you're out in the field and you're going to do this surveying, let's go in that same direction. We're going around the horn here. When we get to point 8, we should say, okay, that's the start of a curve. So we would call that BDY space PC, and then have it, then we would do 0.98 and say, we'll call that one also BDY. And that's going to force it to go through that as a, endpoint of my arc, which is, whatever, either that one or this one up here. And then I keep going and I have, all right, next is going to be a boundary point. Next is this, or we're going to draw the edge of pavement. So I get down here and I start on the edge of pavement. There's 52, there's 53, 54, 55. But then what's coming into those? I've got 56, which is from 54 and 55, and it's way up here is the 56. So it wouldn't make any sense to try to draw things just based on those point numbers necessarily, unless I had arranged them in the order that they would be drawn in. Okay. That's, again, key concept of that, so that the field crews know if they come in and put in a description of EP, that that's going to be a point on a layer called edges of pavement or EOPs or whatever you want to call it. Or you can ignore it in other commands or only use that particular point group in certain instances, that sort of type of filtering. Of course, that often gets turned into, angsty little, sorry, I'm talking to my ex here, but um, so the field to finish part is we want our crews to know as they go through this that they have to, and when they encounter things like this, they have to add these extra codes into those descriptions to help it draw that particular point. So if I were to erase this layer, and if I wanted that code to be, so that went from 8 to 9, but these 100 and the 98 are in there in between. So, it would not necessarily pick those up. And if I'm, again, doing edge of pavement, I'm going to start edge of pavement, and I'm going to tell it when I started arc. Like right here would be the PC, and then PT. That tells it to start and stop an arc. This comes off a tangent. There would be an EOP space PC, and I would get any points along the way, which they don't have any. It's just got the endpoints. And these points weren't surveyed anyway. They were created from the drawing. So field to finish, as long as we use a little bit of savvy with what we're doing, we're going to be able to practically draw the map in the field before we leave there and come back in and run it through field to finish. And most of our work is going to be done. If we are consistent, we use the same description that's in our code table. For instance, all edge of pavement points might be coded EP, but somebody out there in the ground might call it EOP for edge of pavement, or E dash PVT, edge of pavement, any of that kind of stuff. And if those codes are not defined and people flip flop around to different code descriptions, they're never going to successfully be able to use field to finish. So you need that little bit of extra discipline in the field to be consistent with the codes and to be aware of when and where to start and stop drawing your features, but to think about what they are doing is the act of drawing a map while they're in the field based on the points they get, based on the codes that they tell it. Start this, stop that. Use this as a circle. Use this as an offset line. So you can actually put those kinds of commands right into the data collector. You'll see it on your data collector screen as long as it supports field to finish processing, which most of them will show you that map as you go along. And you're not going to walk out of the field then with just a bucket full of points. You're going to have a little map on your data collector screen that looks like this or whatever you're surveying. And that way you can look at it and tell whether or not you need to pick up more points or whether you've missed a particular feature, that sort of thing as well. Okay. So that's the nub of field to finish. And we're going to take a look at some examples of that when we come back after our mid-session break here. We'll go ahead and break till 3:15, and when we come back, we'll start into field to finish and see how that's going to work for us. All right? Any questions at this point? Everybody good? Okay. So I will see everybody back at 3:15 my time. So proud of me. So anyway, let's talk about field to finish and how we can use these point descriptions to help us uh, generate our drawing and our drawing content based on what those descriptions are. And this is going to start on page 67 in your manual. So we're going to uh, create a file. So let me switch back to this. I'm going to close off this file. No need to save it. And I'm going to make a new file. So I'm just going to choose new. And I'm going to set my file name. I'm going to make sure I'm in my survey training folder and my data sets folder. And I'm going to call this F to F in class, meaning that I'm in the classroom doing field to finish. I'll keep it as a 20 scale, and doesn't really matter. I'll keep it as West Virginia North because these coordinates are arbitrary anyway. So I'll just leave it at that. I'll say next, and I will allow it to use that same name for the coordinate file. And right now I could, because the next step in our exercise is to import from a text or ASCII file. We could do it right here as part of this wizard. So we could also have chosen it, pull down the points menu and choose the command there. That's what your book shows you to do. Let's go ahead and do it from the wizard. So we're going to bring in a text file, and we're going to say next.
Hey, Ken, we're not
Yes.
getting the wizard started. Is there a way to get it right now?
You're not getting what now?
The wizard, we're like it.
Oh, yeah. If you didn't get the startup wizard, let me cancel this whole thing. Go to your settings menu, or do you have access to your menus?
Yes.
All right, so go to settings, go to Carlson configure, and choose your general settings button. And it's the very first checkbox at the top.
Okay, thank you.
Got it. All right, so I'm going to close that down and go back to where we were before. I'll just do a new file. I'll click my new button. It's going to pop up here, and with my wizard, I'm going to say set, and I'm going to go to my folder location, survey training, data sets, and I'm going to call this one F to F in class. Okay. And we'll leave it set to a 20 scale, and I'll say next. And in my case, I'd already created, so yes, I'll overwrite. I'll take the coordinate file by the same name, and I'm going to go from the none choice. I'm going to go ahead and import my points as part of this wizard, and I'll say next. And I'll come to this. I have a list up here, a file or multiple files that I want to use. So I'm going to select a file, and the file I want is in my data set, and it's called plat.txt. And I'll open that. So there's the file up here. I could have had more than one, but there it is. The source format is, if I know that that came from a particular vendor's format, I could choose it or just leave it user defined. And I look at my preview window and I know from that experience that that looks like a point number. Then I've got a three numbers separated by commas that are coordinate values. The next looks like a northing, easting, and an elevation. And then I've got a description for the rest of it afterwards. So I can choose any of these pre-built formats, or I can, type it in here if I wanted to do it in a particular order. Maybe maybe the eastings, maybe they're listed as XYZ instead of any uh, northern easting elevation. Here's your little code. That's what these little characters mean. And I'm using commas because my file has commas in it. So that's my delimiter. There is an import formatter that lets you go through and set, much like bringing in an Excel file that you can set, delimiters, column widths, things like that if you'd like. But this will suffice. You can add a certain base value to your point names if you want to. Those are the point numbers. Let's say as they're starting with point number 1, 2, 3, 4. If we wanted these to be 101, we would put 100 in this field, etc. Prefixes, suffixes, wildcard matches if you don't want them all. We do. Um, you can skip any that have a description starting with a certain set of characters that says skip with description prefix. You can skip a number of header lines. Maybe the first line in your file says PT, comma, northern, comma, eastern, comma, ELEV, comma, DESC. So maybe that is a line telling you what the format is. So you would skip that as a header line. And then the range of points, we'll take them all. And when that comes in, do you want to draw the points or not? These are our process options. So process points or process options for draw points, we can say, let's draw them and let's locate points. This is like a draw locate point using the defaults that are set in your points default menu. This would be just like you did using just a standard draw locate points. If you want to maybe change something from those defaults, you can choose this draw locate points dialog. That means it's going to be as if you ran the command draw locate points, but it's going to present the dialog box to you where you can change some things and then hit enter. Or you could just take them from the default without going to that dialog box. Or you could even have it go straight to field to finish. Now that's not going to help us here much because our field to finish code file is not very complete. But if you do this as draw with, let's just draw points with defaults. Point protect, meaning if it finds a duplicate, it'll warn us about it. And we're going to store to the coordinate file. We're going to bring these to our current file. You can ask for another file. You can bring these in. So it's another way of transferring between files. And we'll just say, okay. And when we do that, it says, okay, I read in 54 points to that location. I'll say, okay. And so now 54 points in the coordinate file, draw locate or field to finish or none. We'll say draw locate, we'll say next, and then we will draw all. And there now is all of those points that dump into our file, just a plain old dump into the file. I'm going to go here and set my point style just so it's a little more legible. Set on p-text. I'm going to change that again back to my Calibri Light. Apply and close. And so now you see a bunch of points with their numbers, elevations, and descriptions. And you can zoom in and see, well, here's a bunch of like PV, PV, PV. Those all stand for pavement. There's some over here that say shed, shed, shed. You see they got three corners of a shed. There's a utility pole. There's a fence. There's an iron pin. There's a fence line.
and it's the same point doing double duty. There's an iron pin and there's a, so we could put an iron pin symbol there. It's also part of a fence line. Over here is a fence line, and it uses a concrete monument, which is a 4-inch diameter code. So there's all kinds of different coding. There's EP for edge of pavement. Then there's another EP PT, and you can see this EP comes around uh, across the front of our drawing here. We've got EP starting to here, and it goes up and finds the next EP point there, and it starts an arc. And then it has a point on the curve, which is just EP again, another point on the curve, and then it gets to this point and it puts the PT, it ends the arc, and then it goes up and finishes the edge of pavement up here. So it's going to, in our way of looking at this, it's going to draw this for us if we use field to finish coding to do that. So what do we want to do with finish? So we had one more down. Here's 2 building points, okay? So field to finish is a way of taking this from the field to a finished product, or as close as we can get, or a lot closer than we would normally get. And here's going to be the route that we use to get there. We need a code table. Now, this code table is going to be a list of descriptions that tell the computer, what symbol to use, what layer to put them on, whether to connect them with line work, all that kind of stuff. The data collector systems out there that people may be using, and if you're using Carlson's, that particular field code library that you develop here in the office can be exported to what's called a field code list file instead of an FLD file, which is used in the office. A field code list file lives on the data collector, and you can create it from this field code library, put it on the data collector, and it will actually show you the same thing on the screen of your data collector. It will operate those field to finish commands on the data collector if you want to use that way. You don't have to. Sometimes it's just a bunch of points, or sometimes you get a bunch of points in from somebody else. Um, say a different survey crew maybe, or a different company maybe surveyed the points, and you get the points and you're going to create them from this fact. Okay. So let's start looking at the codes. So we're going to live a lot on this survey menu under draw field to finish. So when we choose that, it's going to tell us, hey, first thing it tells us is your code table is empty. So you can select one that's already made, or you can edit the codes or import codes from another one. So let's select another table. Let's see if there's one that's partially started here. So I'm going to choose that. And now when I choose that, it's going to send me out to wherever my field code tables live. And it is a settings file. It might say Carlson Project settings up here, and mine say settings 2022. Or if I go up and I see all these different, let's just look at the plain old settings folder. I see some things here. I've got one called class example. I've got these different ones, but if I pull down and choose my data set folder, I have some things in here. I've got one called F2F example, and I've got one called man topo. I think this F2F example would work. Let me open it and see. I'm going to edit those codes. And I've got a bunch of, yeah, I think these will match. All right. So when you're drawing field to finish, if it gives you that, you need to set the table. You can also set the table down here in the bottom part of this dialog box. And we're going to set this code table to use the one that's in our folder. So we're going to navigate to our folder in case it points us to a different location. We're going to find F2F example.fld and choose open. Now, the range of points we want to process in this case will be all. So that would be 1 to 54. Again, you see how you can limit it to your point group or click and choose a particular set of points from a list of points. What do we want to draw as a result of reading those descriptions? Well, we're going to do points, and we're going to do any line work associated with the points and any symbols associated with it. And if we have codes that generate 3D faces, we'll draw all of those. You can limit your range that it's going to work within. We'll take all of it. You can give some layer prefixes, things like that. We will check on to erase existing field to finish entities and erase in range. So if we got everything right except for points 10 through 15, we can change this the next pass and say 10-15, and then it would only erase those 5 points or 6 points. And then this preview only is sort of worthless because all it does is it draws. If I choose that, for instance, say, okay, watch what happens. It draws after it gets through processing here. What's going on? Preview only. Okay. All right, there we go. So it draws it as a preview, and that's at least partially better. But now watch what happens as a preview. It said use view menu commands to change views. Well, if you go to view and change these different views, or if you just use the wheel mouse and roll the wheel to get closer, oh, it does keep it. All right. It used to be that this went away. As soon as you rolled the wheel, those disappeared because they're just transient objects. There's nothing there. It's preview only. So they finally fixed that. So there's my little fence line. There's my edge of pavement. There's the 3 corners of my shed. There's 2 points along the building down here. These are my traverses from hub to hub to hub. Um, I got a bunch of points here, PV that weren't coded. My edge of pavement, you see it goes edge of pavement to edge of pavement, starts an arc, comes down and finishes and closes up here. All right, so that's nice. And if I read the line on the command line, it says press enter to continue. If I hit enter to continue, all that goes away. And looks like everything's out of my drawing. So it's all out of the drawing now at this point. So I could, because I told it to erase and redraw, so I could go back and redraw the points. So let's take a look at that again to the survey menu. Let's draw field to finish. And this time let's uncheck that preview only. And now one thing you can do, this is new as part of this, is you can have it go straight into triangulate and contour and build a surface out of the surface type data. It used to be that was not there, that you would simply do this process and then you would go to the surface menu and choose triangulate and contour. So that's a nice little addition if you want to make it all one-stop shop. So let's go ahead and hit OK, let it process, and it's going to come back. And it attaches line work reactors. That's part of that linking. I just hit enter. I think it never finished the command. They forgot to kick you back into the command line. All right, so now what do I have? Now you look at these points, and I've got point number above, elevations to the right, descriptions below. I've got some things that have symbols, some that don't. This is just a raw description, 18D/oak, and I've got 18D/oak. I've got these different things there. Number 6, elevation shed, 5, elevation shed. So a number of things that we could do to finish this drawing at this point. We've got some things drawn, we've got our traversing points. And if I select that point, look at my properties, it's on a layer called PNTS. So if I were to freeze that layer, all the points that are on that layer would freeze. Here's one called UP, it's on a layer called 0. That's not very good. Here's one also on layer 0. Here's on my building, it's on PNTS. So if you were to freeze that layer, you'd freeze the whole thing off. Here's now this line work is on a layer called traverse, but the point is on a layer called PNTS. Okay, so we're going to be able to control what we visibly see here. So if we don't want to see these traverse lines as part of our work, first of all, we'd set our code for this point, which has a description of hub, but it did not draw a description in the drawing. And it said to put that point on layer PNTS. So I would, possibly freeze that layer, but I could also freeze this line that's on layer traverse. Okay, and by the way, keep in mind, these layers do not exist. It created the ones it needed when it came time to draw those layers. So I've got a layer called traverse. It has this line. If I want to freeze that layer, I can do that manually over here, or I can go to the view menu and choose freeze layer by pick, and I could just pick that line, and so that line disappears. And if I want those hub points to go away, if I freeze that layer, and I'll repeat, and I'll pick that layer, you see it got rid of all these other points. Okay, so I'm going to turn all my layers back on and just show you that's how we normally would control this, is based on layer membership. So now let's start up here at our points. Let's go to points menu and list our points. And we see they start, there's that point number 1, which is right up here, the start of that fence line. And it has a description. It's actually a split code. It has a description of FL, meaning it's part of a fence line. So it's going to look up that code and do whatever it says to do. It also has a description of CM, which is our concrete monument, and then it has a slash parentheses 4-inch diameter. Now, the symbol they used for that concrete monument was a square, which doesn't have a diameter measurement, so we need to fix that. There's my hub point, number 2, and then I shoot a utility point, utility pole, and then shed, which was these 3 around these 3 points here. And then it went and found an iron pin, which is also part of the fence line back here. Okay, so it went in this order and created all those points, and they saved it in the field. And now my codes are starting to interpret this and see what it does. So here's apparently a point called shed. It says put the point on a layer called PNTS and also draw lines, which in this case is a 3-dimensional polyline on a layer called BLDG. So that line has elevations at these points that match the point. If I look at the building line down here, notice that, and you can tell by that little midpoint grip, and also in the properties, it does not say 3D polyline, it's just a polyline. It's just a building, they're getting the corners. Maybe they didn't shoot it down at the ground, they just shot it on the corners, and they used it to generate some other parts of the building itself. Again, on that layer of BLDG. Okay, now, a couple of tools sort of outside of field to finish that if you have a 3-point or a 2-sided structure, excuse me, there are a couple of ways that you can complete that drawing. You can go to your survey menu and choose the very bottom command called 4-sided building. And when you say four-sided building, it needs two sides to already be done, one for the length, one for the width. Now I want you to just pick the line or a polyline. So if I pick that, it goes ahead and completes it to the full corner. If I were to select that and say close, it would make that into a triangle. You see, it would go 5 to 6 to 7 and then close back to the start. So this goes 5 to 6 to 7, and then it comes out here and runs this line out to the point opposite and parallel this point, and then closes it back onto that start. Now, I think the way it does, because this was a 3D polyline, we're going to take a look at these slopes for a minute. I'm going to go up to the inquiry menu, and I'm going to turn on my drawing inspector. Oops, sorry, I hit the wrong. It's my layer inspector. So inquiry, drawing inspector on and off. Right now it says it's on, right click to activate the menu. So I'm going to right click, and these would be the things that I would see when I hover over objects. I can see the elevation of something. I can see some polyline data. I can see point data. Let's see if I turned that on and then hovered over a point. You can see as I do that, I'm just hovering the mouse and this is popping up. So I'm going to right click and I'm going to choose this options dialog so I don't have to keep right clicking to get this menu. I'm going to get that up. I'm going to uncheck the elevation and the point data, and I'm just going to look at my polyline data because I'm going to look at the slopes. I'm going to say okay. And so one thing I'll also do is turn on the polyline direction, display the polyline direction. So now I see if I hover in over this, it starts at 5, goes to 6, goes to 7, and look at the pop-up. That gives me a slope of 1.71%. That's on the third line down there of that segment of that. If I hover on this one, that's at 0.94% slope. Now that's coming up, as you see, 501.11 to 53. And so this one was now, what we say, 0.94. If we look at this back leg here, it's also at the opposite slope of its opposite side. It's at negative 1.71% slope, which would then, if you close from that point, which goes back down the same distance to the same, at the same slope as this one comes up, then this one should be that 0.94% where it goes back to its closing, because this one was positive 0.94 and that was negative. So that's how that one works. Now I'm going to right click the mouse and I'm going to turn off my drawing inspector and then just wheel the mouse and the little arrows will go away. Now I can do that same thing on this line down here, but I don't have that third leg, do I? So if I choose survey, four-sided building, and I choose this polyline, it says, well, tell me the offset. What's the width of that building? Well, let's take it as, say, 15 feet. Now, which side? Is it this side or that side? So if I'm on that side, there it is, it's 15 feet. Now that's a 2D polyline, so it's just down at constant elevation of 0. And look over here in my properties, having selected it, it has an elevation of 0. Okay. So those are the kind of a couple of those tools are going to be something we can use in our code table and in our data collection that we can use to create those two features. So let's work on those. That's 18 to 19, 5, 6, and 7. So we'll work on just those features for now on this code table and just get a glimpse of how this is going to work. So let's go back to field to finish, survey, draw field to finish. And this time, before we just hit OK, we're going to edit these codes for a minute. But I also want to look at this additional draw options and show you some different options you can get. And this is to control whether or not to draw attributes and descriptions and point numbers, whether you want to suffix your labels, your elevations and things, or prefix suffix based on whatever a code tells you to use for prefix and suffix in your elevation labels. Locate on the real Z, locate line work on the real Z based on the code definition. And right here, this PC to PT curve type. And these are your options, because what you do in the field is you get on where a curve starts. Let's say you're working at all, you're working around, let's say the edge of pavement or whatever it is. The first point that is the start of the curve, you're going to append another code that says this is the start of a curve. Right now, our code table is reading PC and PT. It can be whatever you tell it you want it to be. And so, and they just need to match whatever you're using in the field needs to match what you're using in the office. So that's going to start a curve. And then it goes from that point of a PC around until it hits a point of the same description, because that's the way it's connecting lines, is using the same descriptions. It finds another point with that same description with a code that says, okay, you're at the end of the curve. And in this case, it's PT for that edge of pavement. But I have 2 points in between it, okay? So when I create this line and tell it to use these curves, how do I want to create those curves? And I have 3 choices: Bezier curves, sequential arcs, or best fit curves. The sequential arcs command will take, we need typically 3 points to define the arc between the incoming and outgoing tangents. We actually really only need the start and stop if it's tangent, because it can compute the radius based on the projection of the tangent lines, assuming tangency. It's not always tangent. And if you, I can't zoom out with this open, but back here where this PC starts is non-tangent to the preceding tangent. But if it is tangent, you can just do the PC and the PT, and it draws the arc in between it. But we do have points in between, and we can tell it either use a Bezier fit curve or a spline to snake its way between. So if you're picking up a sort of a serpentine looking wall feature, for instance, you're going to say, here starts a curve and it meanders, first this way and that way and this way and that way. And you're going to shoot all of the little inflection points where it changes curve direction. And it will take care of doing all of that as a spline fit curve. The best fit option will take every point between the PC and the PT and look at those as points that should be along a true arc between the start and stop. And it will create the arc that best fits through those 4 points. And it uses a least squares algorithm to compute the least amount of variation between those points on the arc and the true arc definition. Now, the other one is sequential arcs, and it takes those 3 points to make the arc. So it would start with the PC, go to the next point, and then go to the next point, and that becomes that arc. And then it would go to the next until it hits the PT, and those last ones would be an arc from that particular stage. Okay, so depending on how many points you get along that curved feature is how it fits the arcs, and it fits them in there. And they're true arc segments every 3, so they're not going to be tangent to each other. They're not going to be like compound curves. They're just going to be curves whose endpoints are shared. Okay. And that's typically what we want when we're shooting these arced features like pavement returns and the noses on parking lot islands, things like that, curb islands that have curved edges. We want to get the sequential arcs version of that, but you can play around with that and see how that works. And then the other options down here at the bottom that we want, these are, oh, this other guy right here in the middle. You can tell it to adjust the PC and PT points, basically slide them back and forth along the tangent direction to the point where it makes the arc between them be tangent, and you give it a tolerance value. That's basically how much you're allowing it to move that point. But, we're not going to do that. We'll just take the points where they are, go with the sequential arcs. And then down there on the bottom, you can rotate text to screen. You can, allow 3D arcs, which is not really, that's a misnomer. Let me see if it explains that in the help system. I doubt it does. Additional draw options. Allow 3D arcs. Let's see what it says it does. So there's adjust PCs and PTs for arcs to be tangential. It will adjust the vertices of the polyline that it draws. It doesn't move the point. It just moves the vertex of the polyline to make the curve tangential. Only adjust these points if the adjustment distance is less than that tolerance. So that's where the tangents are well defined, and the PC and PT are sort of harder to figure out exactly where they are. So that will allow you to make those curves tangent. So that's not a bad switch to have on there if you'd like it. The allow 3D arcs. When creating polynomial arcs with the PC code, this option checks whether to create the arc in 3D. For tilted or vertical arcs, such as a doorway or a bridge arch. That's interesting. We don't often shoot those types of points and then draw them in the field, but that gives you an option to allow that to happen. But that shouldn't actually apply for us down here, but because again, it's going to create that as segmented pieces. It's not going to be a true three-dimensional arc. But it really should say allow 3D arches instead of arcs, I think would make more sense. All right, so I'll set this adjust. I'll let it move that by as much as 6 inches to where it will. And again, it doesn't move the point. It just moves the vertex of the line work. And you can have it create point groups. Let's turn that on for automatically by code and ignore any suffixes. So I'm going to get a group called EP. I'm going to get a group called PV. I'm going to get a group called shed, a group called BLDG, a group called FL, etc., etc. You can have it even do, based on a group that we tell it in the code definition, but we're not going to, I'm not going to give it that option. You put prefix and stuff on the layers, so all kinds of options you can do down here. Okay, and then you can tell it to pause on any undefined codes we want. We'll know that something's undefined when we see it. So we'll say, okay. All right, now, back in our launching area, we're going to edit the codes, and we're going to work on points 5, 6, and 7, and 18 and 19. And so we're going to edit these codes, and those points have those descriptions of shed and BLD. So again, this is where we build up the code library, and we can start from scratch. We can start from scratch and then create a new table that reads everything in the coordinate file and puts at least those in here for us to work on. You've got some points that are maybe undefined, some ground features, fences and walls. These are all categorized based on the group they belong to. I'll look at all. So if I come down here and find I've got house, and it's on a category called structures. I've got shed, which is also on structures. And you can see up here my group called structures. I've got BLD, CONC, HOUSE, and SHED. So that's where those are. This is just a means of categorizing those. So let's come down here and first work on shed. And here's our shed feature. And let's just select it and hit this edit button, or hit the edit button down here in the middle. And let's see what it does. So it's going to say when it encounters a point called shed, it's going to first of all, we've told it the category to belong to is structures. That's where we set that up. Or you could have moved it from there to here with these controls. So here's our code, shed. The full name is just shed. And all this is a description for you to see in this library. It doesn't do anything with it. And this description here is what description to type in or to put in the drawing. Now, in this case, they happen to match exactly. And so you could give it a different description. You could turn that into utility building, and that would be what gets drawn in the drawing. Remember those two different description fields in our point edit. And use raw description on or off. Right now it's set to off. Otherwise it would use the description, just its normal description. In this case, they do happen to match. All right, so right here's our main layer. This is going to be the layer that this is going to be created on. It's going to go on a layer called building. And we're telling it we want it to go on a distinct point layer. So that means it's going to put the points on a layer different from any line work that it creates, which is going to go on BLDG. And the points are going to go on a layer called PNTS. That's our base level of points that we want to see. So we could then freeze that layer, and all of those points layers, everything that lives on that layer would be frozen off. But the line work would remain. And even the symbols, if we used a symbol, we would see that go on a different layer. Now, we're not going to change that. We'll leave that as it is. Now, a couple of other things at the top, we've got these different choices to use. I can choose to use a symbol. I can hit set and either set one, that's in our list of points, or just get this SPT0, which means use none. Okay, so we'll use a little X mark. Our line type, and right now it's just going to be by layer. So whatever layer building is going to be what, or whatever that layer we said it was building. We said it's going to go on, yeah, BLDG. So whatever that's defined as, and whatever color, we'll set the color to be by layer instead of specifically red. And we're going to draw this, whatever the line work is defined on that layer, we'll do that as well. You've got different options here. If you've got custom line styles, you can control. You can even control down here. And there's another option called template where you could create a particular template. We'll see that a little later when we talk about pavements. You can hatch the closed areas if it's a closed figure. You can give it a hatch and select a particular, cross hatch type of thing with the scale. Let's give it a scale of 2. So that should work. And what else do we do? Okay, so now we look at the bottom down here. First of all, we're saying what attribute layout ID? Well, it goes to 1. I'm going to switch that back to 2 just to show you how they're different. Again, there's a point group that we can assign it in the code, or it's going to make a group called shed. I could have a group called structures, and for every code, shed, building, house, whatever, I can tell it to use that point group. Okay, so that would be an option. Now here is my size scaler. That means that plotted inches, so 0.08 inches with an attribute size. If you say allow annotative, that means if you've got a text style that defines those, that is an annotative text style, then if you change the drawing scale, it's going to scale up or down with it. Okay. And now the entity type that it's going to draw is going to be a 3D polyline or a 2D polyline or a line or points only, no line work, or it can be a combination 3D and 2D polyline. Now, right now you see where this creates that 3D polyline that we used to finish that 4-sided building. But what I anytime I'm doing these and I elevate edges up to 3D, if the line work that I'm creating is a 3D line, if that's going to be something I'm going to see in my drawing as part of my finished lines, I generally will always do 3D and 2D, and I will make sure that all of my 3D line works are going to go on a special layer that I'm going to use when I build my surfaces, but I'm left with the 2D down at 0 elevation so that I can dimension all of that stuff in my drawing. So if I had arcs in this particular curve and I said 3D only, I would never see that arc. I would never be able to label what the radius of that arc is. But if I leave 2D and 3D, then I can label the 2D part and it would pick up that dimension for me. So I'm going to set this to be both 2D and 3D. And up here now, I've got a different layer name right here. And I'm going to put this on a, if I'm using a dual 3D polyline layer, I'm going to put the dual 3D polylines on a layer called BRKLN. Those are going to be my break line layers. And I'll set its color to be specifically magenta. Well, let's get it something that I know is going to be not used. Let's see this orangey looking thing right there, color 40. So that's going to be the actual 3D line work is going to be all on that layer called break lines. The point itself is going to go on this layer called points, and the 2D line work will go on this layer called BLDG as my resulting planimetric part of this mapping. The attributes, that's the numbered elevation and description. I can either use an attribute block, a text attribute, both or none. And a text attribute, if I choose that and then choose this setup, it lets me define things like the northing, the east. I can, put all this stuff with it. Point numbers, I can give it the rotations, a prefix, suffix, a position where it goes, centered above, upper right, blah, blah, blah. What order to use, what size to use, what layer, what text style, etc. I'm not going to do that. I just keep it simple and we'll use the attribute block. Now, do you want separate attribute layers? And that means if you create this as separate layers for the attributes, I could put the symbols on a separate layer, for instance. In this case, I would hit my set button and say, all right, for the point attribute block itself, and that's everything, the point number, elevation, description, they're going to go collectively on a single layer here. And then, or I could have the point numbers. In this case, you see, here's my main BLDG layer, and then I get a BLDG, NO, ELEV, DSC. That's my number, elevation, description, and symbol, BLDG mark. Okay, so that would separate those out into different layers that you can control visibility on. So if I said points and then hit set, I get those same ones, but it would separate the point and keep the point back here on layer point. So there's all kinds of control we can use. For right now, I'm going to just keep it simple and keep that set to none. Now, we talked about that type that it's going to draw, and we've got this elevation integers, how many we want to see, all of them, so we're not stripping off any thousands or hundreds or whatever, how many decimal places. And then locate points on the real Z axis, yes or no. And that means it puts the point at its elevation. And if we say non-surface, that means even though it has an elevation, and even if we were to select that point to model a surface, it's not going to do it because we've marked it as non-topo. Again, I'll uncheck that for now. The feature type, I've got topo, tree, pipe, or utility. Now, that is a type. It's going to typically be topo, meaning it's just a planimetric feature here. But when I have these particular types, that gets into like tree surveys, pipe surveys, utilities, and there's certain codes that you can use. I'll show you what that looks like in a minute. That's discussed in those other two training manuals that you have back here. Let me bring this up. Let's see, Carlson projects here too. See, Carlson projects, my class. Oh, wait a minute, where's my class? Here's my class, sorry there. My F2F quick start guides, those are the ones that we looked at. This advanced guide, for instance, if I pop that up, we see that GIS setup symbols. I'm looking for the tree line type. So I'm going to refer you to this for your more advanced education. And they give you, these are step by step, you got data sets and everything you can follow with that as well. Let's see, what was I doing? That's that and that and that. Text versus attributes. Here it is. Starting on page 25, talks about the tree setup. And you have these options in here where you can tell it to draw the block and blah, 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 draw a tree symbol, but make it a factor of a trunk diameter size. And you can set the trunk diameter, yes or no, on or off. So that's a special treatment of the field to finish coding that, again, draw the tree size symbols. Same thing goes for pipes and such like that, although I don't know that he talks about pipe setup and such. They're still talking about the tree surveys. Yeah, so anyway, it's a really excellent in-depth treatment of this whole process. So I'm going to refer you to that for outside study. So now on with us, and that's these down here as this type. We'll keep it set to topo. And we'll say, okay, so we've defined our code shed. We haven't really changed much, maybe a layer or something that it goes on, whether it draws 2D or 3D. But let's look at what else we can do with that particular point in that code. If we come down to our buttons below, we've got code table settings under this leftmost column of buttons. And if we choose that, then these are different processing options that we can use. We'll use Carlson coding. We can tell it to split multiple codes. So if you see a point that has two codes on it, you want to split those codes always and treat them separately. Or if you said none, then it would treat them together and it would look for a code that has a space in it of that same combination. Now, if you are using multiple codes right here, you're saying, when I have a multiple code, I'm going to read the first main code and I'm going to react to that. I'm going to use its symbol and line work. But if I'm using a secondary code behind it, what do I want it to use? Well, I can have it say only draw the symbols. Okay, or I can say line work and the points, or line work only, or line work and not another point, not a duplicated point, but just the symbols. So in the case of, say, the fence line that shares a point number, one of them with a concrete monument, one of them with an iron pin, and it depends on which order you put those in and what you have this setting set to do as to whether it's going to draw the lines and the points. So it would draw 2 points in there. the same number. Or if you said line work only, then it's only going to draw the line work from the secondary code. Or if you said line work and symbols, then it's only going to draw the line work and the symbol from the second code and not try to duplicate the point itself. Okay. So that's, again, we're just going to leave it at the default line work and points. Now these buttons here in the middle, this is where you can export your field code library to a Carlson data collector in that particular format, or Eagle Point, TDS, TopCon, et cetera, and do it by ASCII codes. You can do the same things with these here. You use a spreadsheet editor, et cetera. These other options, again, we'll leave them set for a default, but they control how and where these multiple codes are going to work. Okay, so no elevation points for 3D polylines. If you interpolate no elevation points, even though it has an elevation, you're going to disregard it and just interpolate from the previous ones that were not set to no elevation and have it go on to the other. So it draws the line work instead of picking up the points in between, it will interpolate between those that are marked as no elevation. All right. So we'll say okay to that, leave that alone. And then we look at this button here called special codes. And this is where the magic happens. Remember where I did that four-sided building for the shed from the survey menu command after it was drawn? Well, here's where I can do it in the field as I collect that point. I did 5, 6, and 7, and they're both called 5. Its description was shed, 6 was shed, 7 was shed, and that was it. It went on and stopped. So if I would have used this particular code here called rectangle, and it's right over here, fourth one down on the right-hand column, and it's whatever you want it to be. You could call it SQ to square off the building or whatever. RECT, if I put that as a secondary code behind the shed code, then it means when it sees that last shed code, treat that as a rectangle, and off it goes and squares off the building. In the example points 18 and 19, where we only had 2 points, we would have to put RECT and then specify a direction and distance for the offset. So in our case, we used a 15-footer. Let's say we'll make this one a 10-footer. So we would have said for point 19 is a BLD space RECT, and then we would put a space, and then we'd tell it the direction and distance for the offset. So I would say -10 because I'm drawing from 18 to 19 and I want to go 10 feet to the left and square that thing off. Okay, so you can do that for inlet tops or buildings or anything that you want. So we'll fix that when we edit the point itself. Okay, so a lot of these things, the key ones we want to look at right now is up here on the begin code and end code. This is when you start a linear feature like edge of pavement. You're going to put a EP and then you're going to put BEG, or the defaults might be something like +7, -7. I don't know. There's something from some history, but as long as they match what you're using in the field. So I'm going to say BEG and E and D. I'm not going to use start and stop as in ST and ST because that doesn't differentiate it. So beginning, end, you could just put B and E if you want, but that way makes it clear. This starts a curve, PC, stops a curve, PT. You do not put in a code for points that are on the curve in between those points. They're understood to be on the curve because they exist between the PC and the PT in the point sequence. Now, begin and end, as well as PC and PT, both do not, or neither actually require there to be a termination on that particular feature. Because let's say I'm doing multiple edges of pavement, I can say edge of pavement begin, then EP, 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 and then just finish. And then I go over to another part of the site and I start another edge of pavement. If I just say EP without having said and on the last one, it's going to draw a line connecting those two. But I could also just, when I start the new feature, just type EP begin and EP until it's done. So as long as I have a begin on one point, that tells it to stop what you were previously drawing and start again over where I say begin. Now, I like the discipline of making sure I put end codes on the ends of all these if I want. And you can also do these as multiples. So if I'm doing, um, say, two parallel edges of pavement along, and I'm going to start one, I'm going to say EP, BEG to start the one on the left side of the road, and I go and I get a few EP points. Now I'm going to pop over to the right side of the road and get some points over there. If I say EP begin over there, it's going to close off the first one and start the second one. And then I'd have to go back and try to reconnect on the left side if I'm going to continue that edge. But if you type an EP begin and you start surveying down the line, you jump to the other side and you're going to pick up another edge of pavement feature, you can say EP1 begin. And then now EP is a separate feature from EP1, which while as long as they're still open and still drawing, I can then do EP2, EP3 ad infinitum. And that starts to create those as we go along for the ride. Okay. Then we have a couple of other things here. We've got this CLO that tells it to close the figure you're drawing. So it becomes a closed polyline. So it closes back to the beginning of that feature. I've got some offset horizontals, offset verticals, offset left and right. And that helps me build things like curb structures, that sort of stuff. I've got circles that I can use. I've got this join to point number. So if I have a pole that needs to connect over to a building, I can tell it to do that. And it will connect over to that particular point number. And I've got smoothing commands, jog commands. Jog commands are really handy too. We'll see how that works here in a minute on the building side. So those are the key ones over here. This begin, end, PCPT, things like rectangle and close. But you can see, and there's all kinds of, like there's parking codes, there's sidewalk ramps that you can code in a sidewalk ramp. And if you just look at the help system, let's see if I can find a ramp. See code definitions. There it is. So here we have a ramp code. Then when you observe this feature, you would shoot a point at the start and a point in the middle, and you would type in a distance is where it goes and what these links are. And it builds that entire structure for you in 3D with just 2 or 3 points that you shoot along its edges. So you basically shoot where it starts, you shoot where it comes down, you give it a distance back, you give it a distance forward, and then it comes along and just builds all that for you automatically. So that adjusts any of these offset 3D lines to create this curb structure. Here's your parking stripes, for instance. You get a point here, and a point here, and the spacing in between. It just fills them in for you. Okay. So those codes to use. Now, here's the one that's going to be part of our curve table. Here's our no elevation points. Even though they have elevation, they're going to still carry the elevation. They just won't be considered when if we extrapolate our 3D lines, or if we consider them for a surface. Here's a non-surface NOS. Like the top of a fire hydrant plug is a perfect example of that. I want to make sure I get the elevation, but I don't want uh, that point to be used as part of the terrain model because it's going to be too high. It's going to be up off the ground. some things to rotate and size, different symbols, a particular distance that we go beyond where the point actually is, also in these jog codes over here. And so that will be, oh, up here, so I was looking for this forward slash. When you have a forward slash, that means treat everything after that slash character as additional information to append to the main description. So if you remember, our concrete monument said CM, and it would write out the description as conc mon for concrete monument. And it had a slash 4-inch diameter, so it would then add that onto the description in the drawing. And we have the same thing for, you would append the description of another field code if you used a double slash and gave it the field code. And then you've also got backslashes and back double slashes to do the same thing, but it's not an append, it's a prepend. Or make a prefix of those, okay? So a lot of control. It's going to help us out here. So let's see what we do. So we say, okay, we looked at that shed, and remember we did that four-sided building command, and that is equivalent to that rectangle special code. So if we go to our third set of buttons over here, and let's edit the points. And let's look 5, 6, and 7. That was that right there called shed. I'm going to double click in there, and I'm going to, after shed, I'm going to say space RECT. That just means close that off as a rectangle. And the same thing, I'm going to look at 18 and 19. Now, those were also building points. If I edit this last one to say rectangle, remember I have to give it a distance. So I'm going to say rectangle space -10. So go 10 feet to the left of the line I'm drawing from 18 to 19. Okay. So I'm going to save my file, save and exit. And then I'll say exit from my code editing. And yes, I'm going to save those definitions. And now I'm going to reprocess 5-7, comma, 18-19. So erase and range is in play. I'll say okay. And there it went to, it did that hatch fill. I'm going to take that out of there. I forgot I had turned that on. So there's now that shed that has been created. Here's now my new building. This one, I did not erase that original out of there. It was just line work that I had done. I also had the same thing up here. But this one now has, I can see if I spin this thing up around in 3D, see there's the red line underneath it, which is the ground. And then these up here, there's my 3D line work at the top. Okay, so I'll go back to my top view here. So that gives me nice 3D edges to use for surface building. Down here, this was just a 2D, but it read the distance to go over here as well. Okay. So there's other cases, and we'll finish this out in the morning when we start back up. We're at the end of our day. But we can set these codes up to be, use a tree code, use a certain size of the trees, use a particular line style, like right now. That's basically a straight line, but it's popped in these little these little letters, for like to indicate the barbs on a fence. They're all separate features, so we're going to change that line type to use a nice fence line. And we'll fix this up, and this will come around and draw our driveway for us. And when we're done, we're going to wind up with something that looks like this right here. That can all be done with that field to finish, as long as in the field, we started coding our points, like this edge of pavement here, there could be a 6-inch curb on the edge of that pavement. All we need to shoot is just a point along the feature, and it can go out and build it, come over, build the center line crown, build the other edge of the pavement, and do the whole thing as part of that processing. Okay, so there you can see the different trees. I've got some pine trees, I've got some oak trees, I've got utility poles with the power lines between them. I've got my boundary around my site, around the property. There's my fence line. There's my concrete monument with a 4-inch diameter description. There's a manhole with a sewer line drawn to the next manhole and a sewer line drawn to the next manhole. All of those things can be done as part of your data collection, as long as you've collected those points consistently. And then field to finish can bring this in and spit this out in a matter of minutes, if even that much. So that's where we're working toward, and that will be where we pick this up when we come back tomorrow morning. All right. So let's save your file, and we'll pick that up and finish this off as field to finish. And then we're going to jump over into more of the traditional surveying type things like deed processing, and we'll see about doing a automatic subdivision generation, that sort of thing. Okay, any questions on anything to this point? Everybody good? Okay, you are welcome, sir. Let's see, Scott Steele had to hop off to another meeting. Okay, fine. So we'll see everybody in the morning. I'll send out a new code here after this one. It'll be sometime you'll see before tomorrow morning's class. You'll get an email with the code for the next day. And we will start that back up, same time, same station, and we will wish everybody well until then. All right. And I'll stop the recording.